can turn on and off?
There is actually.
Got it. Okay, good. Get some coffee, orange juice. What happened to these people?
I didn't get to see much of it, it's flying at night.
Are we going to close the doors? Or are we going to leave them open? Talk to me like that. How's everybody doing today? Come on, you can do better than that. So welcome to the 2026 edition of the OpenSIPS Summit. Anybody know how long we've been doing this? Care to guess? 12? 15. Do I hear any others? That was a pretty good guess, but no. I'm betting it's right around 15 years. It really depends on like which OpenSIPS Summit you consider to be the first. If we're counting back from our first Amsterdam Summit, Pete, don't make that face. Don't make that face.
There was summits before that.
There were, but that's really like, remember following Astrocom? Those were the days. So like I said, I wanted to welcome you to the 2026 version of the OpenSIPS Summit. We've got an action-packed lineup of speakers for you guys. We've got some fun that we've scheduled for everyone. The first thing I wanted to address was the companies that made this possible. These are our sponsors, and this year they dug deep for us, showed their support, and I'm gonna call everybody out here. If you belong to this company, please do me a favor and stand up so that we can applaud you. Do we have anybody from 5'9" here? No, stand up. No, please. Let's give these guys a round of applause. Gentlemen, thank you. Our other platinum sponsor, Sipfront. Where are you guys? Come on. Let's give these guys a round of applause. I think we've got somebody from Genesys here? Yes? Somewhere? Yes. There you are. I know there's a big crowd of these guys. Where's 46 Labs? Where are you guys? Stand up. There's more of you. Do we have somebody from EchoSwap here? Yes? There we go, gentlemen. Thank you very much. I think Jonathan's out here somewhere from Connects. Jonathan here. Thank you, Jonathan. Where's our favorite guy from Brazil? The leader of SipPulse. Stand up, Flavio. Thank you, sir. Thank you. I don't think we've got somebody from Inextrix, right? Did I say that right? No. Very, very bad man back there. They are not here, but let's give them a round of applause for helping us out this year as well. And our last sponsor is Voice. We don't have anybody here from Voice either, right? Okay, well, let's give them a virtual thank you again. Okay, so with the sponsors out of the way, we will be calling you guys up a few more times before the end of this. Don't be bashful. I have a couple of announcements. Tomorrow, our first speaker unfortunately wasn't able to make it. So we're going to be moving the last speaker from tomorrow, who is... Come on, here we go. Ian McLaughlin? Ian. So Ian will be opening up for us tomorrow. He was actually slotted to be last. He was gracious enough to keep the rest of the schedule on pace. Thank you very much, Ian.
Come on.
You know, today we have the dinner, and I think 6 o'clock, Bogdan? 7. No, we're gonna meet at 6 out here though, right? For anybody that needs to find their way or wants to move with the group, 6 o'clock outside of the hotel. You call him audible? 6:30. So 6, it's only like a 20-minute walk. Also, you can find the location on the OpenSIPS Summit site. So if you want to go straight there yourselves, you don't have to like walk with us. And then also tomorrow, something that wasn't on the event schedule, we have a walking tour of downtown Bucharest. It's about an hour and a half. We're going to meet here at 6 o'clock tomorrow outside, and there's going to be 2 groups. We're going to have 2 tour guides, and we're pretty much going to split right down the middle. It'll be an audio walking tour, and we're going to see some of the cool architecture and learn a little bit more about the city that's hosting us this year. Let's see. Did I miss anything? I got it all. Now I got to tell jokes for how long? 2 minutes? So I've got about 5 minutes here before Bogdan's going to come up and open up. Nope. What? Oh. Do we have the Liviu bot? Have you checked in with him? It's not a raffle without that. So we do have quite a few nice prizes for y'all this year. I believe the Liviu bot will be online tomorrow. So at the end of our talk, all of our speakers tomorrow, we're going to be handing out some prizes. You'll be given a number. That number is how it is working? We have valid confirmation. Okay, so Liviu bot, what is it, 6 point something?
I mean, it was 4 last year, so we can make it 5.
We can't do 4.1 to keep it with the OpenSIPS release version? No?
Sure.
Okay, so 4.1 will be online tomorrow for your prizes. Make sure that you are here, because if you get a number and we call it and you're not in the room, you lose. You're all disappointed. So I do want to ask a question. Is this your first OpenSIPS Summit? If it is, raise your hand, please. Wow. Wow. All right, who's got 2 under their belt? Don't be bashful. What are you counting back there? He's on his fingers. When you say 7, all right, how about more than 3? 3 or more. So we've got a good mix. Newbies, some of the old guard. Cut enough. All right, so I'm being ushered off stage. We're going to have our keynote speaker coming up. This man is the reason that we're here, folks. Let's give this man a round of applause, please.
Good morning. I hope you had a good trip, enjoyable evening yesterday, good sleep. We have like 4 days, 3 for them, for those doing the training ahead of us. So yeah, you need all the energy. As Alex says, we have a lot of events. Dinner today. Tomorrow we have the guided walking tour. For some of you on the 2nd of May we have some trip in the mountains. So yeah, a lot of activities. And yes, I have to say, doing the OpenSIPS Summit in Bucharest is something that we were almost I would say, dreaming of for a while. In terms of Europe, well, we had to fight against this pretty well anchored Amsterdam. You know, it's I don't know how many years we did it over there. So
not enough.
Well, it's not yet done, so we still have plenty of time.
That's right. We have the future.
We still have a lot of years ahead of us. No worries. Yeah, so we are pretty excited for doing the event over here, even if there were some things not necessarily, let's say, yeah, in our favor, I would say. We had like maybe 10, 20 people not able to join us because of traveling issues. Flights being cancelled over the Middle East or being cancelled because of all this madness with the prices on the fuel. So yeah, we had somehow we took the burn for that. We had actually 2 speakers not being able to show up. One from Inextrix, a sponsor, and the other one, Voice Center, Shlomi, Goodman, and actually they were like a constant Voice Center, constant sponsor and organizer across the years with the summit. So it's a pity they were not able to join this year. But you know how it is. The show must go on, right? So yeah, let's start. I will do an I would say brief introduction in OpenSIPS 4.0. It's brief because that's actually a huge leap forward. We don't have time to go through everything, even so we split this task among the 3 of us. I will just be the first in line. After that, Razvan and then Liviu will continue talking about that. So yeah. Well, I know most of you know me, but I said, okay, let's do what all the other speakers do, with a photo of myself. Is from looking at the T-shirt. It's from 2 years ago in Valencia. That explains the seas in the back. I'm sure. How many of you were in Valencia? Oh, okay, so you know what I'm talking about, right? Yeah. Well, as you know, we as the core OpenSIPS team, we are based here in Bucharest, so that's our home city. Actually, I'm more or less like 15 minutes walking away from my home here. And this adventure in VoIP started for me like in 2001 with the first releases of SER, after that OpenSER, OpenSIPS, and so on, so on. A continuous journey with SIP and VoIP for me. And I hope it will go on because I don't know how to do anything else. So yeah, I don't want to be jobless.
We support you in this.
Thank you. Yeah. And well, you know, OpenSIPS is a project founded 2008. 2 years ago, we officially started the SipHub, which is the commercial part, and you know, in the meanwhile, taking care also of family. You know, proud dad of 2 girls. One of them you met doing the registration. You met Cynthia outside the registration desk. She's my elder daughter. The other one is at school this time. So now getting into the 4.0. We already saw a picture. It was an easy one myself. Now we have another one. Maybe it's not so easy. Let's see any idea who this guy is.
Tolstoy.
Yeah, Charles Darwin. And why he is so famous. Just,
Theory of evolution.
yes, somebody said the keyword, evolution. Because that's the evolution, it's the keyword more or less following today's presentation. Everything is about evolution, also for us as human beings, for projects, for businesses, for everything. You know, evolution basically to be able to adapt to changes, to the new things going around, and that's a must in order to move forward. So I would say you will see later that 4.0 is actually a huge leap in terms of, we would say, evolution in terms of project. Not necessarily from coding perspective, still, yes, it is, but also in terms of, okay, it's a natural transition across the years, adapting to the new, let's say, to the environment, to all the changes in environment. Yeah, I mean, at the end of the day, evolution or adaptation, it's a must. It doesn't really matter, you know, how much of a history you have behind you. If you don't adapt, you are done. That's it, end of road. So we actually spend a lot of time with the project thinking of, okay, what's out there, how do we adapt, how we evolve, because we want to push forward all the time. For example, yeah, we have the AI adaptation. That's a challenge nowadays, right, for everything what's IT related. And even if most of the people, I'm not sure if people among us, but people outside the IT world say, oh, you know, it's the doom, the AI doom, everybody will be jobless and so on. You know, AI will come and take our jobs, and you know, we will go and, I don't know, work in the fields, or God knows. That's, at least in my perception, it's not exactly true, because again, we are talking about adaptation and evolution. So it's just a step forward. And basically, it's more like, you know, what happened in the past, in the beginning of the 19th century, when, you know, we went from manufacturing things, we went to machines, and, you know, we still have jobs. You know, our job was actually to supervise the machines in terms of doing the right thing. So probably more or less the same nowadays with the AI. You know, people have to work to keep the AI working, yeah, why not, to teach it, and to make the right use of it, right? So I don't think we will be jobless if we adapt to the situation. And we see the AI impact in the project. We see it in different ways. Some, let's say, putting some stress, some helping us. For example, it's more common for people to use different kinds of AI tools in order to troubleshoot, to make patches, and so on. So there are a lot. If you look at on the tracker, on the OpenSIPS tracker, you'll see a lot of patches or reports which are AI generated. At the point, it's good because, yeah, from the project perspective, it's a gain. You know, there are more contribution, there are more fixes, and so on and so on. Yet we are still trying to find out, okay, what's the best balance in terms of let's say, reviewing these things because, well, let's say the OpenSIPS code, it's not like a trivial one in terms of the overall concept. There are things that maybe AI doesn't really fully understand, and there are mistakes. I'm not saying about mistakes in terms of coding, mistakes in terms of the design of what it's doing. So yeah, we need to carefully look in all these patches, which is like an avalanche of patches, and that takes quite some time, you know, in doing so. But I would say it's a bit of a burn, but well, yeah, we have to deal with it. On the other hand, the actual development, it gets faster because, as I said, okay, AI will not take our jobs. We will just, how to say, ride the horse, right? So we are using more and more. I think at least in our team, more or less everyone, using different kind of AI tools to speed up the coding. In terms of, we are doing as, you know, the humans are doing the design, the thinking, like, okay, how it should look like, how it will fit into, and so on and so on. And then tell the story to the AI and let the AI do the coding, right? And there are cases, and I'm talking from my own experience, where some jobs to be done may go like maybe 20% of the time that normally took. Especially when you have to, you know, do some small changes, extensions, which have a lot of impact in, you have to go, I don't know how many places and do changes, like different kind of function prototypes, API changes, and so on and so on. So that's a really, really nice usage of this tool because they will speed up everything for you. So yes, sometimes it's, I have a weird feeling, you know, like coding, it's more like telling a story to someone. It's not like spending time actually writing the code. It's just telling to the AI tool, okay, what to do. And after that, of course, taking a look at the resulting code. Surprisingly, even when it comes to simple things, how to say, the choices made by AI are not exactly the best. So in terms of code performance and so on. So it needs a lot of babysitting, let's say. So we do it, we use it, but under control in terms of reviewing the work and so on. Nevertheless, again, it's a huge help in terms of moving things faster. And I mentioned about the environment adaptation of the project, because it's not AI only. Across the years, we had a lot of work to adapt in terms of OpenSIPS as a part of the whole software ecosystem. All the time adapt to the new changes of the libraries of operating systems and so on, or the new trends when it comes to using you know, clouds, Docker, Kubernetes, whatever. So just to be sure that you know, OpenSIPS properly works in such environments. For example, the status report stuff was added more or less when it comes to Docker. Sorry, it's Docker, not Docket. Typo. Just to be sure that, okay, you need a nice status of OpenSIPS when it's starting up, so you know the Kubernetes system knows that everything is okay, and so on and so on. Also, adaptation when it comes to way of using OpenSIPS, more or less coming from the operational side. You know, there are more and more tools on the operational side for monitoring, for profiling, for logging, for God knows what, you know. And all the time, you need to, let's say, meet this kind of new requirements and have OpenSIPS able to export data, provide logs in JSON format, and so on and so on. So again, more or less things coming from the evolution on the operational side. Then new, let's say, requirements in terms of how to use, I mean, for what purposes to use OpenSIPS. Like, you know, I want to use it, okay, okay, classical way, SBCs, PPXs, IMS, okay, let's do IMS stuff. Voice AI, okay, we need to do some integration with different kind of voice AI tools and so on and so on. So you have a lot of new things popping up, and then, yes, you have to align and stay in line with this kind of progress. And also progress in the relation with the community. You know, starting, what was it, last year or 2 years ago? Don't exactly remember. We started the community edition model. So releasing different kind of OpenSIPS-based setups ready to use for different purposes. Right now we have the soft switch, we have the IMS, we have the voice AI, and on Thursday, Darius here will start showing us we are working on. Probably in the next weeks will be officially released. We have also an SBC model for a new addition to the community edition. He will show like how easy it would be to deploy it and start using, integrate with some carriers and things like that. So yes, more or less the keyword here is about adaptation in terms of the software itself as coding, in terms of the environment, and basically this leads us to the 4.0 topic, where again we have quite significant code which was AI produced, new modules, new chunks of code. Yeah, do you need the goggles? Got them.
Who's accusing me of being the model for the picture?
He has the hat beneath the table. And the torch, right?
Looks like a dentist.
Well, it's not my favorite one. Yeah, and besides the AI usage, 4.0, actually,
Are we having a review?
Yeah, 10 a.m.
yeah, sorry. About, we call it revamping, basically trying to change the untouchable parts of code. I mean, parts of code which were there for like almost 25 years, and all the time was like, okay, this works for whatever historical / religious, with whatever reasons, it's there, it works, don't touch it, and all the time go around it, and so on, you know. And they said, okay, now it's the time actually to, how to say, to grab the bull by the horns and start doing changes, because again, everything is about adaptation and evolution. You cannot simply live with forever with the history. So that's OpenSIPS 4.0. That's actually the reason behind this major increase in version. So we said, okay, that's end of the line for 3.0. Let's move with something to a higher version, to the 4x line of releases. Alex, the phone, so I don't know how I'm with the time, just to be sure.
Well, that's unuseful.
Yeah, exactly. It's a blank screen. Okay, thanks. A quick overview. One of the most important things, like the untouchables, the TCP/TLS framework, which was like anchored in the history with the multi-process passing connections and all the madness over there. We said, okay, let's look into it and try to make things aligned with let's say with the new trends, with the new also with the new version of the libraries to make it more efficient. Razvan will be talking more about that in the next talk. Then we did a lot of work in the profiling part for OpenSIPS itself. Again, something coming from the operational side. Actually, that was something like a need felt not necessarily by community members, but also by ourselves. Like situations like, okay, you need to keep to understand what's going on with your software. The big scale forking, again, one of the untouchables. Old history about okay, I can do only a limited number of parallel forking. The never-ending IMS work. This time some interoperability actually targeting IMS with FRAC and update. Liviu will be talking about that. And some cool stuff on the networking side, like the bond sockets, the proxy protocol, and some new concept in the clustering, this bridge replication. Again, Liviu will talk more about it. Just going quickly, that's what 4.0 means in numbers. Usually this, getting this slide was really painful in back times, like going through the Git logs and doing calculations and so on. Now it took me like 2 minutes asking codecs just to get the numbers from the Git repository. You know, it was more like a paragraph of text and boom, got everything. So again, things like adapting and making things more efficient. I will start quickly talking about the profiling with 4.0. Basically, we call this profiling the real-time X-rays machine for OpenSIPS. Because there are cases where you end up in the situation like, okay, I don't understand what OpenSIPS is doing, why it's not processing, or why it's taking too much CPU, or why it's blocked, or something like that. And look at the black box and have no idea what the reason is for not for misbehaving. So yeah, we have this new built-in profiling tool which gives you some information, some real-time information during runtime. The nice part is the fact that it's built-in support. You don't need to recompile, you don't need to restart. So whenever you end up in a situation trying to understand what's going on with your OpenSIPS, you just need to enable. You'll see it's very easy with some MI commands, and you get all the data. The profiling data, it's very simple. It's kind of profiling sessions with logging all the time when some specific tasks, usually the time-consuming tasks, do start and end. So first you can understand exactly, okay, where the code is going, what's the execution flow, and also like, okay, how long it takes. So you can identify, okay, what's going on in terms of execution path, but also if there are some bottlenecks in terms of taking too long. As overall architecture for this profiling, well, we have some producers and consumers, basically. Right now, in terms of producers, we have the script execution, so you can see, okay, what are the routes the execution goes through. If you want to understand, again, the scripting part. But also we have the execution, the processes execution are generating information, so you can see under the hood things like API calls, reading data from the network, and so on and so on. All this data is going to the API where we have some controlling mechanisms, and then it's pushed to consumers. Right now we have two consumers. We have the ability to send this data to OpenTelemetry, so you can visualize it in a nice way. Vlad Paiu will talk about that more today, or tomorrow, I'm not sure. Today. Okay.
Today.
And at the same time, if you want to do a quick, let's say, troubleshooting, you can use the OpenSIPS events in order to get the data. And the plan is to have a new tool in the OpenSIPS CLI to actually read these events and display them in a more friendly way, right, for you. So for the sources, okay, with the script it's pretty straightforward. With the processes, you can see like operations reading and processing C packages, so you can understand okay what the actual process is doing. You can see whenever, let's say, asynchronous or inter-process communication jobs are executed, so you can understand exactly what a process is doing at a certain moment. Or if it's executing timer jobs, that's something that is completely transparent right now. Nobody knows exactly when they are and how much they take. And there are some really critical ones. For example, one of the timers are with request retransmissions. For example, if you have some misbehaving at the SIPHub level, then you have a lot of retransmissions. There is the retransmission job, timer job, which is overwhelmed, but you don't know that in the previous. Now you can actually see that because you see more and more time spent into that time. Then we have the SIP-related API, so you can actually see the execution for certain messages going through DM, dialogue, the B2B. Again, the back-to-back is quite black box because there is not much scripting over there to log. So sometimes you don't understand what's going on. Now you can see it. And also there is data coming from the extra processes. Typical MI processes, HTTP server, and so on. Just an example like, okay, how you can see with the OpenTelemetry. And how you can see this kind of a data through subscribing for an event. This one is for the process profiling. There is a similar one for scripting, and you get like, okay, there is a UDP receiver reading a package, passing to the script execution, and so on and so on. So you can see, the critical steps, so you can understand exactly, what's going on. Control for the profiling, straightforward. We have an MI command to control the level of verbosity for the profiling, incremental, all the way to the most verbose, which is the timer, because timers being recurrent, they generate a lot of data. Sometimes you don't need it, so you can control it. So in real time, through this MI command, you can check in a per process manner, okay, what will be the verbosity when it comes to the profiling. So that's why I'm saying, anytime you can enable, disable, just to troubleshoot, particular, time interval or test or so on, just to understand how it's working. Now, talking a bit about the big scale forking, and this reduces to forking to large number of branches. That was one of the untouchables since day one in SER. The number of branches was limited, and they were statically allocated. So basically, if you're trying to do some really complex, typically PBX kind of operations, so forking to multiple hunt groups and so on, actually it's pretty easy to hit the limit. And basically there was a hard limit. I mean, even recompiling, you could go up to maximum 31, and then that's it. So how the code was designed had to be changed in a way to allow more. We had some situations with hunt groups combined with push notification, which generates more branches, and also with this kind of CLI checking, going to check with external services through regulates in order to do fraud detection, CLI management, and so on, easily going over 80 branches for a call. So we said, okay, it's time to do something about that. Well, simply increasing the number of these static branches, it's not the way to do it. A simple calculation. If you do like 64 branches in all the transactions, if you have like 5,000 calls per second, then only for those branches, so basically for the transaction, the memory will go like, you'll need like almost like 14 gigabytes of memory only for that, which in most of the cases will be useless because only the invite transactions are actually using it, not all of them, right? I mean, a byte that forks, so it will be like 64 branches, completely useless. So, oh, I got a call? No. It's call for N, right? Couple of minutes more, sorry. Besides this static allocation, there was also some internal limitations when it comes to the managing. We had some internal bit mask just to know exactly which branches needs to be cancelled. That's the 31/32 bits, typical integer limitation because of some bit masks. So more or less, we had to do like a complete rework on that. So in 4.0, the branches are dynamically allocated. There are chunks of 4 branches added on demand whenever you need. On one side, you can keep for the non-forking, let's say, requests a very low memory footprint. And at the same time, for invites, for example, you can go like 256. If you really need more, you can even get more than that. Okay, it's just a recompiling thing, but it's possible without doing any kind of coding. That's another sign that I have to finish. Yeah, the conclusions about this forking is right now, which actually you can do like really big scale forking. And in terms of memory, it's even more efficient than we had before, because we don't have this fixed number of branches all the time in all kind of transaction. It's actually on demand and it's dynamically allocated. So spares memory and actually serves the purpose for what you need to do. So that's my part of the presentation for 4.0. Razvan will continue talking about the big elephant in the room we had before, the TCP framework. Yeah. But before leaving, just remember all the time, evolution, adapt and evolve, because otherwise you will not be relevant in the future. Okay? Thank you.
I'm not allowed to introduce you? So, carrying on, we've got Razvan, who will be exploring the first bits of 4.0. Razvan comes to us from the local area. He lives here. He is taken, though. Not that there are any ladies in here. You ready, sir? He's got the fancy thing.
Thank you, Alex. Hello. Hi, everyone. Nice seeing you again, this time in Bucharest. Thank you for coming to our home. Hopefully you will like it and we will come back sometimes. But let's see how it goes. Today I will be talking about me. I live in Bucharest. I live here. I was not born here, but I moved here a couple of years back. And I've been working with OpenSIPS for 16 years now, so starting 2010. I'm one of the core developers, SipHub CTO, and I'm also a father of two boys. For those of you who don't know me for that long, this is also me. Luckily, David, thank you, David. Last year took me another picture that it's more recent and more accurate, let's say, because nobody was.
Less baby Jesus, more CTO.
Yes, exactly. Thank you for that.
You're better now.
I'm better now. Thank you. Actually, yeah, I'm better than the pictures. All right. So probably the most important thing I worked for 4.0 is the TCP framework rework. Let's have a couple of insight of how it was working before I stick my hand into it. So probably some of you know the OpenSIPS architecture, which contains of several processes. We have a TCP stack, which consists of TCP main and a couple of workers, we call them. These are dynamic and can be adjusted according to your traffic. If you have high TCP load, then you have to increase your workers. If you have lower, then decrease the TCP workers and increase the UDP if you have UDP traffic. There's also some UDP workers, chars. These are designed to process UDP, to read UDP packets and process them. And there are also some extra processes, for example, for MI, timers, and all sorts of processes. Again, OpenSIPS, you probably know, is a multi-process focused architecture. What happens when somebody tries to send a packet over TCP? Well, we have an invite here, and they know the APN port, and they are trying to connect. This connect lands on the TCP main, which basically has all the listeners, all the sockets that we define as TCP. There's one process that handles them. So you get a connect, the main accepts it, and then there's a pipe. This pipe is basically like a shared queue, like a signaling queue that all the TCP workers listen on. And whenever a new connection or a new message comes in, TCP main says, okay, I just dispatched this job to one of the available workers. These workers just listen on that pipe, and whenever they get raised or they get signaled, one of them wakes up, and more of them may wake up, which results in under-incurred problems we've experienced a couple of versions back. But in this case, let's say only one wakes up, reads the message, parses it, processes it, and basically handles it, does whatever your logic does. So basically processing means pushing it into script, and your script handles it. You know that. So this is the way the old framework was doing the read. For the write, well, write can be done from any of the processes. Imagine that you receive the UDP message, and then you need to reply over TCP. So in this case, UDP is the one that reads the message, and he's the one that responds. But it doesn't have like a TCP connection. The TCP connection is only bound to one process. This means that whenever you want to send a message, you need to go to the TCP main, which has its own communication channel, ask for a file descriptor. TCP main searches the connection, gets a file descriptor back so that the UDP worker can write on it, and then the write happens. And this is the case where the write is being blocking. If it's unblocking and you need to do asynchronous, then you send another job to TCP main saying, okay, I want to write this message, but the buffer is full right now, I can't do it right now, send it whenever it's free. So TCP main takes it, puts it in a queue, and whenever write is available, so the write buffer is empty, it will trigger an event which will result to an async message being sent again to the pipe and to one of the available workers. As you can see, this framework is not that simple. It has several steps, different processes, different jobs, and different tasks. Trust me, it's not simple. I've been there a couple of times, and it's not easy and it's not nice. So what TCP main does as a summary, handles connection management, waits for new connection, accepts them, it keeps track of all the connections OpenSIPS has, dispatches jobs to TCP workers whenever events come, and coordinates all the write operations. So this is, let's say, the brain of the TCP framework. But there's also the workers, which also keep tracks of connections. So in order to avoid moving connections throughout processes, there's a logic that each process keeps a subset of the connections for reading for a certain amount of time, and if that time overlaps, then it sends it back to TCP main so that TCP main can redispatch it. It's a mess, trust me. But it works, right? Probably most of you already use TCP or TLS or WebSocket or whatever TCP base in your platforms. So the job of TCP workers is to keep track of subset connections, communicate with TCP main to coordinate how to handle those connections, but they also read the message, parse them, process them, and actually perform the write. A generic process, like any other process, whether it's UDP or TCP or timer or whatever, can do the same thing. So they can write a TCP connection if they need to, let's say, respond to traffic from that process. But they need to ask for a file descriptor, get one back, and then they will be able to write. Or eventually send an asynchronous chunk if the write is not available. Again, this was working fine. Under the hood, it's quite complex, but there are a couple of caveats that we were juggling around. For example, a TCP message can be fragmented. It can be received in several chunks. So this means that one process might read a part of the message, and the different process might read the other part. So in order to be able to do that, we need to keep the buffers in shared memory. These buffers are static. They are like 5K, I believe, 65K, sorry, or 32K. I don't remember how big by heart, but anyway. But they are quite big. This results in having very high memory usage in case you have a lot of TCP connections. It has to be shared because, as I said, a message can be read in several processes, so they need to share that memory, which results in a very large shared memory footprint. Any TCP worker can read the message. This is very problematic in case you need to keep context. For example, in TLS, you need to keep the TLS context, which has all the keys and the shared keys and everything. They need to be shared among all the TCP processes. So this means that this context needs to be stored in shared memory, which requires exclusive access, but not just that. And we will talk about this a bit later. Also, more workers need to wait for TCP main, need to wait for information from TCP main. This means that some of the operations are synchronous, so they are not asynchronous, so you can't do very much parallel calls. And again, it's a very, very complex architecture, as you've seen. So our caveats are increased memory, shared memory footprint. I/O operations are serialized, especially the TCP ones, which requires exclusive access to TLS context. There's complex write overhead because you need to get the file descriptor and send it back. And there's also increased code complexity. These are the things that we tried somehow to overcome. I dedicated a special slide for TCP caveats because it's probably the most painful issue we have with this architecture. Contexts are stored in shared memory. This means that we need to somehow modify the OpenSSL library or hook on top of the OpenSSL library in order to allow us to use a shared memory. And that worked fine until 1.1.0, OpenSSL 1.1.0. That worked fine because they provided the hooks for us to do that. But they were removed in 1.1.0. Not sure why. I actually dropped them a ticket to ask them why they do that and saying, okay, this no longer works for us because we no longer have those hooks. And they responded, okay, it was never documented to use it like that. So we realized that they were not going to adapt or at least make backwards compatible with their previous, and they actually said that. Their statement was, okay, we want to use like a very new approach, like a newer approach based on threads and so on. So we realized that we have to do something. And we've tried several hacks over the years. We even hooked into the big thread externals in order to override the usual locking mechanism and guard them with shared locks, the shared locks we have. But it was not enough. That's because they said that they want to be threat focused, so that was their claim. So we were no longer, at a certain point, starting with 3.x, we were no longer able to overcome all the limitations or all the things that they tried to that they reworked with. We even added Wolf SSL module in order to try to overcome the OpenSSL limitations. But the problem with OpenSSL was not just OpenSIPS itself. It was the fact that, for example, you only have one instance of that library. So if you have that instance, you use the shared memory for that instance, all the other libraries will have to use it. For example, MySQL, Postgres, REST, and Chicken were all affected by this limitation of OpenSSL. That's why we added Wolf SSL to be able to use signaling for something else and to avoid hooking all those shared memory stubs in OpenSIPS. Again, it worked fine for a while until 3.x. That was somehow a turnaround. The downside with OpenSSL is that we can use Wolf SSL, but for example for REST, we used to build it with new TLS just to avoid using OpenSSL because it has all those stubs. But that was removed in Trixie, not sure why. But curl no longer was with new TLS, so we have to use OpenSSL as well. So that's why we created the new framework. So let me guide you in the idea we had. So instead of having the connections spread across several processes, why not have them in several threads? So keep them in a single process. That would basically avoid having to share the memory across, having the memory in shared memory and spreading it to multiple processes, but would also no longer have to have the context shared. This means we will no longer have to have our custom hooks for shared memory or for locking, but we will also adhere to OpenSSL threaded vision, right? So it seemed like the right way to do it. So we started as a proof of concept, of course. So the framework changed something like this. So the TCP main will have several threads. I only put 3. We will still have the workers, we'll see later on. When the connect is received, the TCP main accepts it, because accepting is quite lightweight as an operation. But a thread would read it. So not the main TCP process, it will dispatch a job to a thread to read the message. Of course, if the message comes in different chunks, it may be thread 3 and thread 2 reading it, the entire message, but it's still the same process. So we don't really need to, this means we don't really need to share, to store the connection in the shared memory. We can keep it local. We still use that pipe in order to dispatch the jobs to processes, but again, we don't dispatch a read job. The read is already done in a thread. We only use the pipe for the workers to process it. So a worker wakes, parses the message, and processes it, and that's it. So you might notice that it's a bit simpler because some of the jobs that were done on the workers, have moved in these threads. For a write operation, it's even simpler. So even whatever generic process you have, when he wants to write, it will just send the write to TCP main, and the thread will handle that. So that's as simple as that. You don't really need to get a file descriptor or move context across processes. No, just simply dispatch a job to TCP main. This was not simple, so it was a radical change that impacted all TCP protocols: TLS, TCP, WebSocket, BIN, MSRP, SMTP, all of them. But at the end, we simplified the code and architecture a lot. TCP connections are still in shared memory, but their contexts and buffers are in private memory. So this helps us reduce the memory footprint a lot. I/O operations are no longer under shared processor pthread locks, but rather on the more lightweight locking mechanism than the shared one. So the operations are a bit more efficient. For OpenSSL, which was a pain in the ass, let's say, we completely dropped the shared context. So all the contexts are in the TCP main threads, so we no longer need to share them. This means that we no longer need the memory hooks, we no longer need share synchronizations, we no longer need the hacks that we've done and just to try to work it out. But it also means that it will not interfere with other libraries. And we will also adhere to OpenSSL philosophy, which basically means we will use the library the way it was documented to be used, as well as keeps door open for any other features that OpenSSL offers. And there are a couple of them. So basically, what's changed is the TCP, for the TCP main, is still doing connection management, waits for new connection, but it doesn't accept the connections. The threads are doing that. It also keeps track of all the connections, but no longer handles any file descriptor, no longer dispatches jobs to TCP worker, coordinates the operation in its own threads. And the threads, but it dispatches read jobs to the threads. It also partially reads the message. For example, for TCP, you need to partially parse it in order to find out the message length, to know how much you read for that message. And just dispatches jobs to TCP workers. TCP workers basically just parse the message and run the script, and then write jobs to TCP main. So is a generic process. So as you can see, there's a lot of logic that disappeared because we simplified it and made it more efficient. The outcome is that all the TCP protocols run smoothly, well, just as they were running before, right? Well, with some caveats for the OpenSSL. Then you might say, okay, so if everything works just as fine, why are you having this presentation? Why are you losing your time? Because we are proud of it. We worked a lot and we are very proud of this new rework. Thank you very much. Actually, no. Let's see some. This is not my presentation. No, let's see actually why. We wanted to test this. We want to see whether it behaves better or it's worse. Because we had very, very strong feelings on this. We didn't know what to expect. So what we've done is created some synthetic tests using some TCP generator for generating traffic and some SIP in order to reply back. So the scenario is very simple. You generate TCP, send it to OpenSIPS, OpenSIPS sends it to UDP, SIP, and reply back a response. In our case, was an option. So it's roughly small packets that were split in several chunks. So I made sure that the TCP generator splits the message in order to also test the fragmentation. And every test consists of 30,000 connections with a 500 throughput. Again, this was run on my computer, so it was not a stress test, it was just a reference test. We just wanted to see whether it behaves better or worse. And we run every test 6 times, basically, one wrap up and 5 times in order to find, like, let's say, similar results, and then computed the average. And this is what we have. So, for example, for a connect operation, on the old version it took 2.4, on the new version is roughly 2 milliseconds, so 80% improvement. So this is like the average. On the tail, so at the end of our test, the connect took like 3.8 milliseconds. The old version, the new one, is 2.85, so a 26% improvement. So this is the connect operation for For the round trip also improved from 1.17 to 0.50, so 50% improvement. And at the end of our test, from 3.55 to 0.88, so 75 improvement. So as you can see, luckily, our new rework is way better than it was before. So multi-process, the OpenSIPS multi-process architecture isn't necessarily helping us in the case of TCP. And moving to a newer and more, let's say, modern threaded architecture made it way better. Of course, the work does not stop here. We need to do a lot of improvements. For example, we only do asynchronous jobs, so we don't really know the outcome of the write operations. Well, only the connects, but that's a different story. So we need to have a way to feedback the outcome of whether a write was sent or not, because we simply attach an asynchronous job for now. We need to improve the dispatching of the TCP jobs, but also opens us a lot of new features. For example, we may be able in the future, in the near future, to unify the TCP and UDP in a pool of workers that basically do the same thing, like read the message, handle them, and reply back. Okay, so this was the TCP framework. Again, we are very proud of it. It works very well. Some other stuff I work with is the proxy protocol. How many of you have heard of the proxy protocol or used it? A couple of you? Yeah, nice. The problem of proxy protocol is a classic, basically, when you have an application proxy. So imagine you have one or more OpenSIPs, and the proxy, not necessarily an SBC, but a proxy that is an application layer, in our case, for example, Cloudflare, and the phone. So you have your customers not go directly to you, but rather go to an application proxy or firewall, for example, Cloudflare. What's the problem? You advertise to your clients the Cloudflare IPM port, but when they send a message from IP P to IP proxy, when Cloudflare proxies it back to you, you will not see the IP, the real IP of the client, but rather the IP of Cloudflare. So at the signaling level, you will see the IP of Cloudflare, not the client's IP. Not sure what P comes from. It stands for. Don't mind me. And it's easy to handle this at the application layer. For example, Apache or Nginx uses the X-forwarded for or X-real IP headers in the HTTP message. Postfix or Exim uses the received header. OpenSIPS can use VIA or route or X-real IP if you want something custom. So this can be easily sorted out at the application layer. But what about TCP or the transport layer, TCP or TLS? Well, that's what proxy protocol is being used for. So it has been developed by the rtpproxy team, and it's now supported by all the major cloud providers and all the major open source projects, for example, MariaDB, RabbitMQ, Performance, Love, you name it. And the idea is quite simple. Instead of sending the message, or when sending a message, also append a line with the real IP and real port of the source and destination packet. So it's just this. It's like a plain text line appended to every single connection. And we've implemented that in OpenSIPS. You can easily filter whether you want to receive proxy protocol or provide proxy protocol. So when you stand as an SBC, you can provide the information at the transport layer. You can do that for UDP, where every packet has to have this line, or for TCP, where only the initial packet needs that line because you didn't keep the connection. The only downside is that for TCP or W or WebSocket connections, it actually breaks the protocol itself, because whenever you do a TLS connection, you don't do just the native TLS connection. You first have to send the line before doing the handshake and you have to send a line with the real IP anymore. But yeah, this works. We support protocol version 1, which is like a simple plain text line, but there's also version 2, which basically allows the proxy to exchange TLS certificates between the real customer, Cloudflare, the endpoint, so that they can negotiate and authenticate clients without Cloudflare knowing. And we may also add some simple protocol, which is a Cloudflare proprietary, or not proprietary, Cloudflare made protocol. It's similar to proxy protocol, it's just a bit shorter, like uses less bytes. Well, so in conclusion, we managed to do to simplify the TLS framework, but not only just simplify it, but also improve performance for connection and round-trip latency, and also sort out the OpenSSL limitation that we've had so far. And we also added proxy protocol support in order to provide visibility between proxies at the TCP layer, and also have a stronger fit for Cloud Age and SBC proxies. This is it. I think I'm a bit out of time. If you have any questions, we can discuss it in the coffee break. Thank you so much.
Where's Liviu?
So there.
Next up to continue the 4.0 discussion is Liviu, another core developer. Who's having fun? Wow, what a vibrant and unsettled crowd. They're ready for this.
I'm ready as well, I guess. Hi everybody, it's great to have you here in Bucharest on this special edition of the summit. I am Liviu Chircu. I've been an OpenSIPS developer for the better of 14 years now. I guess 13. Just for fun, can we have a show of hands if there's any tech person in this room who finds themselves not, who used to write code, but within the last year you find yourself not writing that much code, if any at all? So yeah, I don't know what I am nowadays, but probably a reviewer, code reviewer, you know, a babysitter for AI. Yeah, so I don't know, but yeah. I do my best to make platforms better and make OpenSIPS better. So what I'm going to talk about today is some cool stuff on how we added. Okay. Good work, Dan. Yeah, that's a good one. On the MS front, with some added interworking capabilities, cool optimization problem on cluster replication, bond sockets, and some upcoming TLS news. So on this prac stuff, if you're not familiar with it, just one slide is enough to get you up to speed with RFC 3262. The purpose is just to make sure, so we have in SIP, we have confirmation when a call completes, right, the ACK, so they wanted to have some confirmation when the early session negotiation takes place, right, just to make sure that until the call is answered, you get provisional media, and it's done with an extra method, the prac, right? That's all good. We're just a SIP proxy, right? We just relate between the agents what could go wrong, right? Well, in real life, it's not that simple because let's say the caller doesn't support it. So it can start failing in multiple ways. Let's say here they don't advertise. This is a little feature tag, the 100 rel in the supported headers. If they don't put it, the call might get outright rejected. Or it could go through, but the UAC requires it. I mean, of course, the the UAC can play nicely and reject it, right? But we all know in real life it doesn't work that way. They will just ignore it, and after some time, the server eventually gives up. Okay, you're not sending me a prac. I'm cutting down the call. So, or it could fail on the other side, where now on the left side we are imposing, right? We put require on the UAS, and now it fails that way. So now we find ourselves in this situation where, you know, we're somewhere in the middle. We have like a legacy system on the right side, you know, that doesn't support these IMS extensions. Yeah, let's call it that. It's probably just as old as SIP, right? This 3262. And on the other side, you have the fully compliant system, and you need to kind of bridge the gap. You need to kind of make things work. Like a big discussion popped up on the users mailing list somewhere in November. You can see there was a lot of people involved. Giovanni, Johan, Alexei, Antonis, yeah, and yeah, there were more threads. You know, we like to talk on the OpenSIPS mailing list. We use it. Karsten, yeah, we use it. And there were some references that, like at industry level, there is support for this kind of middleman handling, right? Some commercial, like probably most of them, can act as an interworking SIP user agent. Specifically, I think we talked about the Oracle one. And it kind of looks like this. You can see that there is this conversion from mandatory, right, requires, all the way to optional, supported, right? That doesn't mean that you're okay even if they don't support it. So that's for the right leg here, where they don't have the support. And of course, on the IMS leg, you handle the pracs yourself, answer them, and you add, right? So on the early 180 packet, you have to append the 100 rel feature tag. So what ended up looking like in our implementation is something pretty similar. So yeah, just a quick look at the call flow. I'd say they're pretty much, going back a bit, they're pretty much the same, right? So this is on the client leg. On the server leg, probably similar, right? Now you kind of do the same mirroring, but now you're generating the pracs from the OpenSIPS instead of answering them. Pretty similar. And of course, we made that happen as well. It's actually more complex here because the invite could get forked downstream, and you end up with multiple early dialogues. If you're familiar with the idea, yeah, I don't want to get into too many call flows, but you could have multiple 2 tags and multiple RSEC, the R sequence numbers on the pracs, and OpenSIPS needs to handle them carefully. If you see here, the invite run 2 phones in parallel, and we have to prac each early dialogue. Okay, so how do we enable all this in 4.0? It just goes as easy as it's just auto prac, you know. If you want to, you know, to let OpenSIPS do the work, of course. If you want to get your hands dirty, there is some little extension we made to DLG. If you're familiar with this DLG send sequential request, it can now do prac. It's a bit weird sequential, right? Because we haven't 200 ok'd and ACK'd the dialogue, but it still has a 2 tag, so it's a mid-dialogue request before the dialogue is confirmed, you know, so it makes sense, right? So it was the right place to add it to. We didn't want to, yeah. So there's that. There are more parameters I will get. Let's check the time. I can talk a bit more, I guess. So let's say we want some fine control when we are answering the pracs. Here is where actually we actually should cut the call if there is no prac coming from the client. So we are trying to script this in OpenSIPS. Of course, it's completely possible. You can do this kind of a technique, we call it the launch sleep. Give it a couple seconds for it to happen. And if it times out, you load the dialog context, and you can reply to the invite transaction, right? You need to connect it, so this launch doesn't have any transaction attached to it, but you somehow need to remember the transaction ID from the invite, and then you just reject the invite. Also, the same thing can be said on the other leg. Right now we are producing the pracs. Here is optional, up to you if you want to cut the call if it doesn't get answered. Practically, I even talked to Vlad about this at some point. There is no need to, right? If it doesn't get, you should let things go through. Just ignore it. It's just a prac transaction that didn't complete. You can just But yeah, if you want to be rigorous, you can also connect, right? Because we have two transactions again. We have the prac that we started, and we need to connect it to the initial T1, the invite, and shut it down, right? Give it a something, 5xx reply. So it's possible with OpenSIPS scripting techniques. Yeah, you can, for example, quickly go through. There is some time. You can attach some fake headers like X transaction ID to the prac transaction, catch them in local route. This is the second layer. We catch them here, remove it, of course. We don't want junk in the prac to flow to the other side. Thank you, Alex. And arm a failure route. So if that happens, if that were to time out, let's say, you can connect back into the initial transaction and answer it. Of course, if you want to enable this, there is a little option if you want it to be more strict, but by default it's false. It will, just ignore the prac transaction failure. And last but not least, speaking of IMS, there are also update packets sent between the user agents. If there is no support for them on any of the directions, right, there is the option to convert it to a reinvite, and the scripting looks pretty similar. There are two transactions. There are some differences, right? You now need to know the to tag, but you also save the data into the as ADPs, right, into the second transaction. So first we had the invite, we do this fake headers, now we catch the reinvite in the local route, store the ADPs so that we can reject the initial invite if the update were ever to fail. A mention can be said here that it's still, so this works if the call is established. There are also updates being sent early dialog. For those, we don't have a full solution, right? Because you're not allowed to send too many sequentials before the call completes. So you kind of need to act as a B2B, answer it. Going back to the industry solutions, you look at Cisco, SBC, and how they handle this. They just do 491 on the update, right? It's early request rejected or something like that. So they don't support it either. But at least there is some more ways to bridge some gaps. Maybe not all. We can see maybe in a further iteration we can convert even these updates to reinvites, right? Because it doesn't make sense. My call is not answered yet. How can I convert it to a reinvite on the outbound leg, right? You have to do some really dark magic to kind of answer it yourself and kind of start playing with the signaling. So it's a lot more complexity to have that interwork. Yeah. Okay, so the good news is that all of this is unit tested. I mean, let's say end-to-end tested, system tested, well done. So we got a big suite of SIP regression tests for all these scenarios. If you look, there are tests for the UAC side, for the UAS, for manual mode, auto mode, success, failure, all kinds of combinations for the prac and for the updates. It's all pushed into the SipCert, OpenSIPS tests repo, and hopefully still passing. But yeah, it's great that we can iterate on that and yeah, make sure we don't break things when we make changes to dialogue and any surrounding areas. Yeah. Next, a bit about the optimization problem. This is a fun one actually. Yeah. It only pertains to rate limit and the CPS counters there. I'll shortly describe everything just in case you need one second. An update there. So what's the idea with rate limit, right? You keep track of you want to limit the calls per second, right? That a customer can route through your platform. Here we have customer 1 and 2 putting some traffic, and we have the counters for each of them. Simple. Let's scale this up now. So we have multiple OpenSIPSes, and the same customer is pushing traffic to both of them, right? Now they need to be aware of each other, right? If let's say customer 1 pushes 10 and 10 to each OpenSIPS, but they only have 15 CPS limitation on the platform, they are currently pushing 20 and getting away with it. So they need to start sharing the data, right? Your OpenSIPSes. Of course, you can use a shared database. You know, there's endless key value databases to choose from. But at the end of the day, this is some sort of a round trip. It is some sort of an overhead that you might not want to add up to your setup time, right? It will increase your PDD and so on and so forth. So I mean, this is not anything new, right? We had this for like maybe 4 iterations now, 4 or 5.
Jesus.
The holy pentagram, yeah? Yeah. Yeah.
That's an oxymoron, holy pentagram.
Yeah. So the idea is just have OpenSIPs cluster together, your OpenSIPs boxes, and they share the counters, and this happens behind the curtains, right? It doesn't affect your setup time. It's just the numbers are there, updating at whatever frequency you choose. Easy way to configure it, right? Cluster, yeah, the cluster module. But what was the problem we ran into, or this specific customer? Is I mean, I can give name, you know, it's public info, but I don't want to name a shit. So they had multiple data centers, and they only had not that many OpenSIPs in each. But the problem is that already, even with 9 OpenSIPs, it's a full mesh replication. There's a lot of lines in there. So, and it goes to the wide area network, to the internet. So just one data center, it's 9 and 9. It's 18 connections to the pipe. So it starts hitting the limitation, right? The bandwidth limitation, especially if you want some frequency to it, like replicate every 4 times per second or 5 times per second. So okay, we had to optimize in some way this thing and have them share data in a smarter way. Let's take a look at what it looks like now with bridge replication. Boom. Much simpler, right? We identified that there was a lot of redundancy happening in this one, right? The same packets were kind of sent, and we came up with this idea where you can have multiple clusters and they aggregate data at each cluster's level, right? And now that data gets published between clusters. So specifically to rate limit, of course we kept its replication timer. So right, let's say intra cluster still stays and they broadcast right full mesh here on the timer. But now there is an additional timer that says, okay, I've aggregated this data and I'm now pushing it out. Quite simple, right? To neighboring clusters, to whoever is connected to it. On another interval with another expiration, similar. This is what the table looks like. There's a new table to define these connections. You get like full flexibility. You can choose which nodes to replicate to, and of course the source. Let's start with the destination first. We just use a simple failover. If it bin protocol is TCP, right? So if it forever cannot connect to the first one, it just fails over to the next one. And now as far as the sending part goes, there are these sharing tags, right? You're probably familiar if you've used Cluster up until now. The nodes share this tag, which can either be active or backup. There is always so active is at most one. It's not possible for two nodes to be active to have a sharing tag active. I mean, we know it can get into that state, but that's bugged. So if you do that, then it's no bueno. So you could configure it in such a way, right, that you get the most usage out of it. If I go back to here, you can see cluster 1 connects to 3 through to this B3 node, but connects to 2 through the B1 node. So you can get spread the workload, right, both for the replication effort and for the retrieval effort across all of the nodes using this table. And right, the sharing tags. So that's pretty much it. It's quite a simple concept. And let's say one limitation on the initial release is that it's only with the tail drop algorithm. Maybe there's like 4 algorithms in there. We've only tested with 1, but we will probably make it compatible with all of them soon enough. And as far as what other modules we could enhance to benefit from this bridge replication, to my mind, only come the dialog profiles, since those are much a similar replication pattern where you broadcast periodically, update some data into the other nodes. So for sure, those could solve future bottlenecks there as well, the bridges. Next is are these bond sockets. So what is the problem we had here? You oftentimes get a different combination of sockets to different layers. So let's say on the customer-facing side, you get, let's take the example here, right? Some IPv4, UDP, IPv6, or IPv4 and 6 over TLS. But on the carrier side, a different, you don't have the TLS IPv6, let's say, and even more so to the media servers, where you only want to be doing IPv4. And also, yeah, they can be, you can group them by fully qualified domain names to add to the problem. So not only do you have this complex logic of matching them, anytime you need to send to a carrier, right, you need to double check the dollar socket out to make sure it goes out to the correct socket. But sometimes you might not even be able to do this. Let's say, going back to the fully qualified domain name, you don't know what it could resolve to in order to select the proper socket. So it's left to the operating system to select one for you, but that might not be what you want, right? It could select the wrong one. So that's why we came up with the bond socket idea, which groups the sockets to be used when going to certain destinations. And it matches the address family and the protocol. So for example, here we could make 3 groups, right? One for customers, one for media servers, and the last group of sockets for the carrier side. And the scripting would look something like this, right? We have, we know this, we have our sockets, but now we can define some bonds between them, and we just take them and put them into a list. It's not, it's quite simple. And when we use them, we can set the socket out to a bond, and now OpenSIPS will correctly match the family and the protocol and pick an interface that's done in a predictable manner, not something random. And this is on the outgoing side, but also you can use the bonds to check for incoming traffic as well. You can do this. Socket belongs to bond function call and match traffic to whatever bond you want, and simplify your scripting at the end of the day. Otherwise it would look like a bunch of if else. Yeah, let's say. this wasn't much of a development effort, but it's kind of cool. I wanted to talk a bit about. Are you aware of these changes in the public internet coming in the next month? Yeah, on the cryptography. So, long story short, they are restricting the domain of the certification authorities, the public CIs, will give you certificates with restrained scope. So you will no longer be able to use them as a client, right? Let's say to connect to a TLS server, you will only be using them to listen, like a web server, or of course it probably applies to SIP as well. Here's a bunch of news. You will have access to this presentation. Yeah. If you want to read more. But concretely in OpenSIPS, we used to do this, right, to put the same certificate both for a server domain and for a client domain. But often it was because we were required to do so by the scripting itself. So on the client side, you always had to put in the cert, the private key. So this might be problematic once this EQ sunsetting really goes into effect. In that now your OpenSIPS will be connecting to a server that doesn't necessarily require it to present a certificate. To say, okay, I didn't ask for one, but it hands out this server wrong one, right, without the client auth OID, and the connection might get rejected. So TLS has this little way of doing the handshake where you just don't send a cert. It's completely fine. But in the script you weren't able to do so. So okay, we made a small change. You are able to skip these and hopefully have less problems when this whole madness with EQ sunsetting comes up. So yeah, that was it on my part. All these, we have blog posts on the crack things if you want to get your hands dirty. Yep, and bone sockets. And yeah, I'm not sure if we have any time for questions, but
We do not.
Thank you so much for your attention.
Sandro, come on up here, buddy. If you do have any questions for Liviu, try and catch him sometime around the coffee break. We are running about 10 minutes late, and we are going to eat in a little bit to the coffee break. You can thank Bogdan for that. Do we have sound from the computer? I do not know. It's possible.
We'll find out. All right. Sandro, just use the HDMI. Oh, okay. I'll find out. Yeah. Let's see if I can have some display.
Maybe toggle your output.
Does someone have an HDMI to USB-C? Yeah? That might do it. No, it's All right. Sorry about the delay. So yeah, my name is Sandro Gauci. You might know me as the author of SipVicious, the security scanner that might have hit your SIP servers in the past, or still. I have no idea. It's not me. It's people out there who have, things to do. But yeah, this time I run a company called Enable Security. We do penetration testing of voice over IP and WebRTC systems applications. So this time I'm going to present something new, which is called DVRTC. And what's DVRTC? Well, that stands for Damn Vulnerable Real-Time Communications. And the damn vulnerable part might hurt your ears a little bit, but it comes from the cybersecurity, from the hacking sort of world where people have created a lot of intentionally vulnerable training platforms or systems that you can download, such as Damn Vulnerable Web Application, which is a set of PHP scripts, a web application simulating, a bank or something like that, that is vulnerable to all sorts of web application security issues. Well, Voice over IP didn't really have one, a proper one, and now it does. So it started as an internal demo server, a server that we would hit when we were developing our tools, SipVicious and SipVicious Pro and other tools that we use internally for our work, day-to-day work. We need to test against something, so we created a demo server. And that's like 5 years ago, something like that. It's been a while, but it was never public. And we have been promising to make it public, but had to clean it up a lot and so on. And now it's publicly available, the source is available, it's free for internal use, and we call it real-time communications. Now, the current release is 0.2. We already released the first one last month, I think. And today we have two scenarios. The first scenario is what we had since 5 years or so, which is PPX1. We call it PPX1 now. It's based on Camellia, Westeros kind of RTP engine. And we just made available a new scenario, PPX2, which is based on OpenSIPS, FreeSWITCH, and rtpproxy. And you can run this locally using Docker, Docker Compose, or you can test against our online servers. So, if they go down in the next few minutes, I know who it is. So yeah, go ahead and pull it down and reproduce everything I'm about to show you. You can actually do that. I have a slide that shows where to get it from, but it's on GitHub. Why did we make a second step? Why not stick with the first one? Well, different people run different components. Some run both platforms and so on. So yeah, there's a lot of stuff more out there, more than what we had in the first scenario. But the interesting thing is that you can have the same sort of vulnerabilities in different scenarios across different stacks, right? You might have SIP extension enumerator or password cracking on different stacks, but the implementation details might differ. You're going to have different configuration surfaces. You're going to have different default behavior, which I think is important, and you might have different exploitation paths. And of course, there are some vulnerabilities that are, specific to one scenario and not the other. So, it's really important to have all these different scenarios if you want to learn through something like the VRTC. Learn, security for voice over IP and WebRTC from an offensive and defensive point of view. And of course, this OpenSIPS community should have its own scenarios. So, that's you guys. So, yeah, this is the new stack, and it consists of OpenSIPS, of course, for the signaling, rtpproxy for the media relay, and behind those we have FreeSWITCH, and there's Nginx to help them out, and it's all done using Docker Compose. We're using host networking because we didn't want to have the NAT issues that we were trying to always solve with these sort of small environments. One box should have each scenario, basically. And there are some, attacker-facing. The attacker-facing services are OpenSIPS and rtpproxy and Nginx, but of course you can still reach FreeSWITCH, and there's SQLite and recordings. I'll get into that soon. But compared to the first scenario, the PBX one, this is a simpler, more focused scenario, more focused stack. All right, this is how it looks like. So it's relatively simple, very simple actually. But yeah, FreeSWITCH is using SQLite for one demo, one exercise. So that we're going to show for SQL injection. And rtpproxy is configured to store recordings with the PCAPs, so that's another demo as well. So in terms of attack surface, we have implemented these sort of vulnerabilities. This is not what you usually hear, right? You don't hear someone implementing the vulnerabilities, but in this case, that's what we actually did, so that you learn how to not implement them by mistake, I guess. And yeah, these are the attack surface vulnerability signaling vulnerabilities that we implemented. The most common ones are enumeration and password cracking, of course, but there's also SIP digest leak. I'm not going to go into that this time, but it's implemented in OpenSIPS, and there's SIP clients, bare SIP running as well in the background, helping out demonstrate some of these issues. And then on the media, we have, you can, of course, analyze the SIP and RTP traffic. If you are man in the middle, because there is plain text traffic there. RTP bleed, thanks to rtpproxy, RTP flood, thanks to rtpproxy as well. We can show that here. And then we implemented a Lua script within the FreeSWITCH dial plan, which we've seen during our penetration tests in the past. Very similar script to what I'm about to show you pretty soon. And yeah, there are 10 exercises which you can follow in the documentation. And these are all reproducible using automated scripts. So it's all, there's Python scripts and bash scripts that allow us to make sure that the vulnerabilities still exist when we do an update. And you can check that the system is working well by knowing that it's still vulnerable. All right, so I have some 2 demos, quick ones. The first one, which I'm going to load from here. All right, there's no mouse. So it is. think I'm missing one video. Yeah, I'm gonna have to skip this one. So what we were supposed to see here is there's RTP proxy, which is storing PCAPs. Now try to imagine. There's RTP proxy storing PCAPs. PCAPs are being exposed through Nginx so that we can see them. And there's a tool called rtpfluff.py, which starts a call using invite, and then instead of sending RTP at a normal rate, which would produce, normally sized PCAPs, it sends RTP with large payloads, around 60,000 bytes, and at a high rate, 50,000 packets per second, for example. And in just 3 seconds, you get, 2-3 gigs of PCAP. And that could be a problem in certain scenarios where you have, PCAPs being generated, and someone can fill up disks and cause all sorts of problems like that. So that's something that is quite often overlooked. If there is no sort of rate limiting or anything like that, that's going to be a problem, right? But yeah, I'm not here to discuss the solutions at this point. And then we have an SQL injection vulnerability that we have implemented. This is a bit more complicated, so the RTP flood is the simple one. So what we have here inside FreeSWITCH is 2 interactive SIP extensions. One is called 2001, which is publicly available service. You call it, it tells you, hello, welcome, I'm trying to connect you, and then it says, sorry, cannot connect you. And then there's the extension 9000, which is kind of a backdoor sort of thing that is not really accessible directly. So it's only accessible through some weird way, one of which would be SQL injection. So the goal here would be to call 2001 to reach 9000, because they have the same entry point through there's an SQL query which is determining what happens. And the dial plan looks like this in FreeSWITCH. So you have the destination number, anything starting with 2001. We can make it a bit more realistic, but I was under pressure for the conference. And then it runs the Lua script, which sets certain variables in the dial plan. So this is the only public entry point for the demo. And the database is seeded with this sort of information, these sort of values. And you have again, one is public, the other one is internal. And the Lua code, of course it's a bit longer, but it looks something like this. You have the dialed, which is gotten from the SIP URI that is being called, and the number that is being called, and then the dialed value is being appended to the SQL query. So that's a classic SQL injection, and you might say, "Oh, come on, this is such an obvious." But it's actually what you see in the documentation of FreeSWITCH, the public documentation. So it's a copy and paste type of problem, and we've seen this in actual live environments, similar, of course. And so, yeah, then the script sets those variables which are used in the dial plan, which determines what happens, how you reach 2001 or 9000 in terms of destination. So normal lookup, 2001, injected lookup should lead to the internal extension. And this is all based on SQL injection. So I have a video. Oh, the video is working. Yes. So how can I actually? I'm gonna have to switch here because I don't know how to use the mouse. And this. All right. So we're gonna call 2001. And when you call this, because the audio does not seem to be working, maybe. I don't know if you can hear it. I switched it on now. Ah. And how's the mouse isn't good. Just. All right. So what's happening here is we're calling 2001 first, and that works, of course, but doesn't lead to anything. It says, okay, sorry, you're not allowed. I'm sorry, Dave. You know, from the movie from 1970 something. But if you pass a single quote, then it will fail after the 2001 because it gives an SQL error in the background. But if you pass something like 2001 single quote and closed, it will go through because it returns the same thing as you get in when you pass 2001. So the SQL returns the first value. While if we decide, okay, let's try a different string so that it doesn't match, then it's going to give an error 480 in this case. So again, we know that there is something interesting here. SQL seems to be working because there's a positive and negative, test. And so the trick here is to use, something like this, where I'm appending an SQL query using union select after n and 0. I'm going to explain this soon. So access is granted, that goes through, that works as an SQL injection. Great. So what just happened? Well, yeah, union and 0, which is, so from the quote, I don't know how to use this. I never had a from here, from the quote onwards, it's injected, right? Or actually, yeah, it's injected SQL. And 0 for SQLite means, suppress the normal row, the normal result that you get, and after that you can put your SQL query that you want. And of course, the last quote, we didn't have to type it in because it was already part of the original query. All right, fine. But you're of course quite skeptic to see this sort of demo because, how does the attacker know all this information? It's all a bit far-fetched, it's very staged, right? So that's where, you might use something like SQL Map. It's a great tool for web application penetration testing. People who have used it, it's always impressive to see it, after a while of not having used it. It's a great tool because when you point it to a web application that has SQL injection vulnerabilities, it often finds them, and not only finds them, but is able to dump the whole database, sometimes within seconds. Right? It's really effective, and attackers use this, so yeah. But of course it doesn't support SIP. So what we did is build a harness, a bridge between HTTP to SIP and vice versa. I'm not going to go into that so much. Let me try to use All right. So this is going to go a bit too fast to explain everything, but I'll try. All right, so the VRTC comes with an extra container, not just the vulnerable services, but also an image which you can spin up the container called attacker that has all these tools that you need to demonstrate these things. So it's really well packed, really nice to use, I hope. And yeah, we're going to run this harness tool, which starts an HTTP server. We're going to tell it, hey, use PBX2 mode, and hey, target this this IP, the IP of the SIP server that we're targeting with this OpenSIPS, which passes all the SIP to FreeSWITCH. And it starts up an HTTP server on port 17771, and then we're going to point SQL map towards that URL, tell it, hey, target Q, which is the parameter that is injectable, use multi-threading so that we don't have to wait forever, and dump everything. Temper means modify the requests, because certain characters are not allowed in the SIP URI, so it encodes them. And at first it takes a while until it determines what is this, what sort of SQL database are we talking to, and so on and so forth. And but then it starts running through it, and it's reading from the master DB of SQLite to get the structure of the database, and and then it starts getting the values as well, which are the things that we wanted, right? Sorry, so that's a pretty cool way to exploit some SQL injection by using existing really good tools out there. So what's missing? Well, there's no WebRTC, there's no turn, code turn, or anything like that. There's no SIP to process scripting. That's in PBX1. But of course, I'm interested in what you guys want to see. What sort of vulnerabilities have you seen in the wild? And what should we implement next? Especially with FreeSWITCH. FreeSWITCH has a lot of room for having vulnerabilities. Things like ESL and XML-RPC, which might also be exposed on OpenSIPS as well, could be really interesting. I don't know if we have time for questions. No. So yeah, on Thursday there's the workshop. We can discuss then. The idea is to secure the VRTC and fix these security issues and discuss how to fix them. So in terms of resources, yeah, you can scan that. You can subscribe to our newsletter as well, which is about voice over IP security and global ITC security. Comes out every month. And the repository is on GitHub. The live system is on ppx2.wprtc.net. Thank you.
Okay, we're going to have actually a shorter coffee break. Today's coffee break is coming to you via Genesys. Let's give them a round of applause, please. Thank you gentlemen for the refreshments. What I prefer to do is we've got about maybe 15 minutes. I want you to go out there, stand up, stretch, grab whatever you need, bring it back to your seat. We're going to get started again in about 15 minutes.
You're next, yeah. You gonna need your full 30? Yes. Okay.
Actually, I'll do it.
That's not so good.
That's not so good.
Not so good.
Well, in the last 3 or 4, I did. We're going to talk about troubleshooting. Troubleshooting SIP like pros. Troubleshooting is something really important and costs us. Hello?
Yeah.
Better. So we have to talk very close to the microphone. No problem. Okay. So just to introduce myself, my name is Flavio. I'm kind of a family guy. This is from 3 years ago on Athens. Yes. It's always a good time to get together with a little more sensitive.
Yeah.
Better?
Yeah.
Better! Okay. So in Athens, I started with OpenSIPS in 2008 when it was called OpenSIPS. 1 week before the book, Bogdan just said to me, we are splitting the project, now the name will be OpenSIPS. Okay, let's write another book. Okay. Well, today I'm going to talk about 35 employees in Brazil. Half of the team is tech support. I have more tech support than developers, actually. And this is kind of funny because Brazil is a little different than the rest of the world. Brazil have some interesting things like we have 20,000 internet service providers. In Brazil is a very large country, and we have very small ISPs. And just for telco license, there are more than 2,000 telco licenses given to companies. Some of them are very small. So we take care of more than 1,000 servers in the company. If you get all the clients and all the servers, there's a lot of servers and a lot of tech support. So we do more tech support than anything in the company. And it's 50% of our costs. And scarce. Here, most of the guys here are bald because this thing about SIP not very good for the hair.
Still got mine.
It's something like, oh, broke again. What is this time? We are getting old, and it's becoming harder and harder to find people. And it's the #1 reason for sure. So if you can't find the problem, it's a pain. You are going to lose the customer. If you're on a subscriber business, what's the #1 concern you have? Sure. Because you're going to lose, let's say, if you're a wholesaler, you know, if your call's not getting through, or if your ASR is bad, you're going to lose the traffic in 30 minutes. So to find the problems very quickly, it's very, very important for anyone. Where the time actually goes, most of the time. And 80% of the time is just getting the information for troubleshooting. So what usually used to happen in the past? And someone called it tech support. And after calling tech support, someone will call the guy and say, what happened? Let's see, let's reproduce your problem. That was our instruction to people. Reproduce the problem, get the evidence. Evidence most of the times is log and pcaps. And then someone will analyze. So we have a 2-tier. The first tier is just to grab information, and the second tier to analyze. The problem is, sometimes it takes 3 days. You have to call the guy, let's reproduce the problem. I can do it today, maybe tomorrow, I have to go to the customer, and then the support takes 1, 2, 3 days, and this is bad. And the second part of the support, 20% of the time, is analyzing the collected information. That is also hard. Right? How hard it is. So we spend 4 times longer collecting data than solving the problem, and this is something we are going to look here. Like We have to SSH into the boxes. We have to use ngrep, fantastic tool, logs, CDRs, containers, and doing everything by hand. And even the 20% is not easy to do. You remember this game? I love it this when I was young. And this is called intrinsic motivation. So we love to do it. We love to solve problems. Right? And it was my favorite. And that's why I brought today this one. The 7-error game, the SIP 7-error game. And so let's practice now. So, okay, what are the 7?
2 from tags.
2 from tags.
2 from tags. What else?
Yeah,
The branch doesn't have the magic number. 2.
The tags on the 2.
The
tags on the 2 header.
The tags and 2 header, yes. 2 tags. Huh?
CSEC method.
CSEC. Yeah, it's register instead of invite. It's wrong. 5.
Ports and O's. Max forward 0.
Max forward 0, 6.
Is there something correct?
Max forward 6, and there's a still one.
Content length is wrong.
No content header?
No, the content length.
Ah, the content length is wrong. It's one of the 6, yes. What else? Yeah, it's already counted.
Oh, there is no content.
There is no content header. That it's mandatory. Huh? 7. Well, so it took us almost a few minutes with probably some of the best SIP engineers in the world. It would take a lot with junior engineers on the system. But today, if we look at cloud, and we could just show here. There's 7 errors on the SIP packet in a second. Right, so AI can spot these patterns very easily on the system. So what we have to do to troubleshoot, let me go back to the presentation. What's the idea here? What do we need to solve a problem? We need 2 things. The context and the intelligence. So the idea of the SipVolt is not a product, it's just an internal project we have. What was the idea to improve the troubleshooting? First thing, to have every information beforehand, not after. So I will not wait for the user to call the tech support to have the information. So I want to grab this information and send to Vault. And this Vault has several uses. First, we have to keep the CDRs for 5 years. This is a regulatory. Second, we need to keep the backups because of ransomware. So we need to have them someplace where it cannot be modified for the whole time. And third, we can have the PCAPs, logs, and everything indexed by the co-ID. Another interesting idea is I don't want to have a huge database because having too many customers is difficult to separate everything and put in a database and search for the database. We already have the CDR. I remember some time ago on the OpenSIPS, I don't know if you have seen on the OpenSIPS control panel, there was a connection to Homer, direct, and this disappeared at some point. And one thing that I wanted on this project, I want to connect the CDRs directly to the Vault. So I just have the co-ID on my CDR, connect to the Vault, and in the Vault I have the SIP, the CDR, the logs, and everything together. So the idea of the SIP Vault was to have the SIP packet, RTP and RTCP stats. Let's say if you're using rtpproxy, you can export in using HAP the RTCPs. This is something most people don't know, that you can get the quality information of the call directly from the rtpproxy. Right, something, it's there, but it's kind of not hidden, but most people don't know. We actually, after this, we created an agent that it's a little bit easier. The OpenSIPS logs and the CDRs, everything in the same place. So after, the first version was using OpenSIPS trace, and with the trace we get the PCAPs and the logs, and rtpproxy RTCP packets. And the second version, we decided to create an agent because sometimes we have OpenSIPS in one server, RTCP in another server, and rtpproxy in another server, so putting an agent is kind of easy. So the idea of the agent is very simple. It's a Go agent. You receive the SIP, RTCP, and logs, and send to the Vault server. That's basically an S3, and everything indexed by the call ID. Nothing else, the simplest way possible. Right, so two capture modes, eBPF and libpcap. We kept the libpcap because we have some old servers using CentOS 6 and 7. 7 mostly, I hope. This is a problem. When you have 1,000 servers, okay, let's update the operating system. Huh? Nice. Huh? A lot of work. And there's a problem. We cannot use the cloud because Anatel does not allow the packets to traverse the internet. You need to have the local infrastructure there, unfortunately. Zero dependency, so is a Go binary, very simple. Outbound only, it survives disconnects because they have a local buffer and can run on AMD and ARM. From customer edge to AI analysis, so you have your OpenSIPS, you send all the requests to a SipVault server that it's a large buffer just to write to the S3 server. Then there on the SipVault server, we have a fast API plus MCP, where we send to the dashboard, and also to Cloud Code, we have created a skill and an MCP server to troubleshoot the calls. Let's see this. Oops. Okay, so this is the CDR viewer from OpenSIPS. So for the demo, I decided to put everything here. So this is the link to the Vault. If you look at the link, you're going to see that we have hash, an HMAC hash, just to implement security. So you need to sign all the requests to get the information from the S3. You cannot simply use the call ID. You need to have a secret there. The system generates the hash directly, so I didn't have to change the CDRs. This is our OpenSIPS CDRs. Normal CDRs are just added the new link on the Vault, and then we connect the Vault. So this is a normal call, and in the Vault we have all the audio information. I just warned Alex that I will blow up the time today, and this is by design. And so you have all the information regarding the latency, MOS, packet loss from A to B. And this is important to understand what's the problem if it's on the source or on the destination. Then you have the packets, so you can watch the signaling here if you want. Then you can have some graphics. And finally, we have the OpenSIPS logs, and we can ask whatever question we want here. This is a way to do it, to have this little box with AI where you can have an assistant. This is good for the part. But you can also use the inside code. Like, I'm trying to avoid any problems on the demo, so I did it beforehand, just to avoid. So this is a troubleshoot call. So when I do a troubleshoot call, it calls the SipVault MCP twice. I have added to the SIP vault the current configuration of the OpenSIPS.cfg. So it has in the context everything, so the logs, the PCAPs, the RTCP, and the OpenSIPS script. And then I just say troubleshoot call. It has a skill, and it's showing the call. So it's basically saying the dialog completes cleanly. You have the invite 407, everything right. Root cause, it's not a config bug, it's a bug on the phone. And it was actually, I was testing push notification on an iOS phone, and the iOS phone was not opening the audio channel after receiving the push notification. Right? So you got the whole thing. When you were troubleshooting things like voice AI, that you need additional context like the live kit logs, plus the agent logs, plus everything, it becomes a nightmare to get all the information in the request. But now we have something really interesting that is to me it's a breakthrough. It's if you have the context and you have the intelligence, the skill, you can solve the problem. So the secret here is to upload the whole context of the problem you are trying to solve in some place, and then you can create a skill to look at this problem and help to solve it. It's not something, it's not a big secret. Most of the people can do it nowadays using AI. And it's very helpful, and I believe it will help to, not to reduce the amount of people. We need more and more engineers. And this is something about AI that my comment about AI. People are saying, we're going to displace a lot of people. The unmet demand of software is huge. Like computers. When computers were expensive, there were 10 computers in the world. Now that computers are inexpensive, the amount, the time.
It's very expensive right now.
It's very expensive right now. But let's say, software was really expensive. Yeah? And now, let's say, the unmet demand is huge. We have, let's say, when I started this thing about cloud code, and how many of you are addicted to cloud code? Wow.
It's a real problem.
It's a real problem. It's a real problem. There are a lot of wives complaining about cloud code. Who's this cloud that is taking all the attention? And how many of you are working on 10 projects at the same time? I'm not alone. Nope. And so, what's the problem? Why this is happening? Because there was an unmet demand for software. We needed better software for CRM. We needed better software to troubleshooting. We need better software for so many things. So the demand for software is exploding. It's different. People are saying, we are going to displace a lot of people. No, you have to hire a lot because now we need to build more software. There are lots and lots of new problems. Okay, so let's begin. So, as you have said, so every CDR now carries its own evidence, call quality, end-to-end, and per lag. The bad lag lights up red, very easy to spot, very easy and quick to spot. A cloud code skill that reads the vault, so you don't have to. So you just have to do troubleshoot call ID. It goes to the MCP server, gets the information regarding the call, gets the information regarding this OpenSIPS.cfg. And if you can insert the whole information, you can spot the problem very quickly. What's the advantage of using cloud code for troubleshooting? You can add more information. Let's say I have the logs from the phone that are not in context. Copy and paste, and then you can keep troubleshooting using the cloud code directly. What happens after you hit enter? it starts to, it fetches the context, it correlates the data, reasons on the problems, and report what's going on. There was one of these presentations here. No, it's not this one. Sorry, just want to take another peek at one with wrong answer. It takes some time to show. Just let me go back here. So when it's doing, it's calling. It's doing getting the call context. And after getting the call context, it processes. It takes sometimes 4 minutes, so I won't spend all this time. But it will show you, what's the idea? It was showing you that he could spot at the exact line of the problem. So when I was rehearsing for this presentation, what I was doing is commenting the TOM reply on the rtpproxy answer. And then the system was able to spot this line is commented, it's causing a problem. So it's quite easy to. So, what to take home? What I want you to take home is, the way to solve the problem is, first, 80% of the time, get the information in the context. Right? So all the information. If you have, let's say, voice AI, you need more information than what you have here. Second, use an MCP to bring this context to your AI, and then you can solve it. Questions?
You use Claude AI. Does your company have privacy concerns?
Yes, we have. For the vote, we are not using Claude Code. For the vote, we are using GPT-OSS 120B. Right, and we are not using directly Claude, but anyway, we are using an external system. We are using Grok. Not Elon's Grok, the other Grok. That it's super fast, and we use a lot of use a lot of open source models. Quen is a very good model, but let's say people are so used to Claude that it's let's say it's probably easier for most of the people to use Claude. But you're right about concerns. There's questions about LGBT here and many things. That's why it's just troubleshooting tool. Most of the people won't have access. Sandro?
Have you given any thoughts to, injection, like prompt injection?
Not yet.
All right. Good luck.
Good luck. Yeah, it's true. It's something that we have to pay attention. On the, let's say, on the vote, the GPT-OSS 120B, there are guardrails, but I don't know if they are enough for now.
The agent and the vaults implementations, did they need anything specific to your setup, or is it just generic?
Just generic. You can use GPT-OSS 120B. Now I would say Quen and even new DeepSeek, they are fast. Let's say, how many of you have changed your model, your favorite model, more than twice in the last 3 months?
What if they're all your favorite?
Huh? Yeah. We now have the second opinion codex.
Much like you, yes, second opinions.
How many engineers have you hired after implementing this?
Well, we have some open open slots there. But do you know we are thinking to add more forward deployed engineers for projects instead of having. We want to have less people on the tech support and more people on the customer. Because what I see as an opportunity right now is we have a fantastic tool to deploy solutions. In the past, let's say, how many opportunities have you said no because you don't have time to develop some specific feature or some specific do some specific work to get the deal? Let's say in the last, let's say, 5 years, we are this we can support. This is a little different. We don't want it because it's a lot of time. And now we say, okay, let's do it. Let's do it. We are safe enough to say, okay, let's do it. I can change the. Let's say, to exemplify, 7 years, maybe 10 years ago on Java and Glassfish, to change one field, you have to generate a new EER, test everything, 1 week to change one field in the interface.
How are you with the accuracy of the numbers that it's giving you? Have you verified them? Because most AIs are too eager to answer quickly instead of correctly.
It's true. It's true. The latest models are quite good, but you still need supervision. You need someone doing and verifying everything. Let's say
babysitting.
Babysitting. Yes, we are becoming babysitters of AI. Yeah, it's true.
We're finding that with CDRs that it's hallucinating 90% of the time when you're asking the questions about it.
Yeah, I think you can use the prompts. Another thing that we use a lot when we don't want AI to hallucinate is to add more context and, let's say, forwarding to the RFC 3261, grab some information and attach the AI to some specific information, especially to avoid hallucination.
We're normally answering it with double check your work.
Yeah,
And then
you
it
have to
fixes it.
double check. But the more context you give, the less it hallucinates. The more context you give, the less. The problem is, if you have something that's standard SIP, it will answer very quickly. But if you have something that, let's say, if it's not available on the internet, AI will know too. You have to provide more. If the information is sparse, you have to put this information in context. They don't learn things that are very obscure. So it still has some troubleshooting OpenSIPS itself, because there's not a lot of information on troubleshooting and config examples. You still have to babysit anyway, but it's much faster. Go ahead. Sorry.
Like I'll support with OpenSIPS to send this data to as a agent to capture the practice
Yeah, you can do it, but as I said, I want to have the information beforehand instead of after.
But now you have like second SIP step that passing SIP again in
Mm-hmm.
different way, not in the same way like as you made SIP step with serving code to it. Because your SIP step implementation is different, not the same as OpenSIPS.
Not the same as OpenSIPS. I could grab the information from OpenSIPS. You can go to the trace using JSON RPC and grab directly from OpenSIPS. The problem is when you do this, you have to implement. We have to take care mainly on wholesale providers that OpenSIPS is already full of tasks. And if we implement directly on the SIP stack, we run the risk of having issues with the performance of the whole application.
But it's more random if you have agent on the same server. Also
not necessarily. You can run on the. You can mirror code if you want. I haven't tested with TCP, but if you're mirroring, it will work too.
No, but in your code you have only UDP.
My code I have UDP support, but most of the cases are still UDP. Okay. Let's give Flavio another round of applause. He's had work done since. Thank you so much.
Okay, we've got Giovanni and Rocco.
Rocco and Giovanni.
We all know Giovanni? Ready, sir?
Hello, we're so happy to be here for the many times. And okay, we're running OpenTelecom in Europe, and it's not so interesting. But then we will talk about observability and how you can have all your data at your hand and let's say on the interlapping between what you do and what you want to know. So this is something that I think we all has been into. Yeah, we feel something is wrong, but all the indicators say, okay, I mean, you are your dashboards that are green, no red alerts. And so this is the kind of platform, an example platform, one of our with usual things, the outbound, the inbound, the DIDs, and high availability, scalability, those things. And you have three kind of perspective when you interact with a platform that is from the business side, from the technical, and from, let's say, the third tier. And you want to know, as a business person, probably your customer, how they can make more money, more or less. So upsell something or sell more quantity of the same things and these kind of things. And check a pulse on what their customers are doing before they call you. And then from a technical standpoint, that's probably the first and second tier of support. You want to have a clear view of what is happening in this moment, possibly without changing so many clients. So without going from logs to statistics to this and that and that. And it's very simple. I was so fascinated from Flavio. Okay. And then you have the third tier, that is probably ourselves, that want to go in depth and to see what is really happening and why. And so we have from one side OpenSIPS that do his own things and it do very well. But we want to know at each step what is happening, why, how much, how each gateway is behaving, what his customers are behaving, because maybe they are sending a peak of traffic just while the first two gateway in that route are having problems, so it's full of 503 and let's say those things. And so we instrument, we at each step of the processing of a call, you put something that ingest data and statistics into the statistic engine of OpenSIPS, that then we will see there is Prometheus, Grafana, and those things. And so to each step, its own data gathering. And then now we pass to the actual step of doing that in a way that is not taxing on our operation, and that gives us all the answers that we would like to have. And I pass to Rocco.
Thank you. So it's my first time here speaking. I visited quite a lot, and I hope you can take away something from this presentation. Our main idea when implementing this was that we don't want to have anything unnecessary in the OpenSIPS part. So we do a lot of windowing, ratios, averaging. All of that is taken away from the OpenSIPS and done then in Prometheus on top. The main idea is that in OpenSIPS, we simply add something to a counter when something happens. That's all we do. And because of that, we do not grab any shared memory logs, we don't do anything, we just have log-free atomic writes. And the OpenSIPS side stays log-free. We differentiate between 3 different kind of values that we are interested in. The most basic is a counter, where we only want to know a quantity. So how many calls are incoming per second. That we simply do a +1 for each call that is coming in, and we know our value. Then we have values where we care about also the value itself. For example, MOS is a value, right? It's 4, it's 5, it's 3, it's 2. We care about that. Or also billing duration. How many seconds did we actually bill for a call? And then we have values where we are interested in a concurrent value, right? For example, how many concurrent calls do we have? Connected, trying, ringing, and so on and so forth. So there we do a +1 and then a -1 when it exits the status that we are interested in. And this is how it looks in the configuration. So as you can see, it's super simple. That's also the main idea of it. It simply has 2 parameters. You call the route. One is the metric name, for example, gateway, XY, AUF or no AUF. And the other one is the number, right? For example, 1 or the actual value of that metric. And what you see on the bottom is how we call it. And as you can see, for the same event, for example, normal gateways, we manipulate 4 different metrics. Why do we do that? We do that so that we can aggregate across a lot of dimensions. So we can see how a certain customer is doing, how a certain gateway is doing, how a certain source IP is doing, route. So those are our main dimensions that we want to aggregate upon. And I've already told you that, but everything else is in Prometheus. Currently we have, for example, 50,000 active series and quite a bit of calls on these specific platforms. But it's no worry, you can have as much as you want, basically, because you only do these writes. And all the math, which is quite complicated, as we'll see later, is done in Prometheus. So you can scale it basically not to infinity, but to a lot of metrics that you collect for a lot of calls without having any problem. And then in Prometheus, you aggregate them along the dimension that we've already seen, customer routes, and then you can select single customers, single routes, dig down into your data. And we already saw this diagram where we had like the questions, okay, some questions that we want answered along the processing of a call. So for example, how many of our calls pass authorization for a certain customer or for a certain source IP. And here you can briefly see what we're collecting at what step. We are collecting much more, but this is like a snippet of what is collected where. But how does it look like then in a dashboard? This is a very standard dashboard in Grafana for the ones of you that know it. Our dashboards are configured that we have the main dashboard to see a broad overview of the platform if everything is okay. And then we have specialized grade dashboards that we'll see later. This is super simple. You simply see the numbers that we take from Prometheus. No graphs, no aggregation, not much. You can, for example, see, okay, 700 connected calls. Some stuff is red because, for example, a lot of gateways are blocking us. And where it gets more interesting, this is still the main dashboard. If it was on the website, you could simply scroll down to get to this view. And you can see the graphs, right, of our trends. It starts at 9 in the morning, so you can see the daily ramp up of the traffic that we have on this specific platform. And you not only see the lines, but you also see these bands. And these bands are also computed in Prometheus based on the data that we collect. And they show what we are expecting for that time of the day to be normal traffic or a normal value. So for example, we can see that this day is a bit of a slow ramp up, so the line is rather at the bottom of the band where we expect it to be, but it's still within what we expect. So you can quickly also see as a visual cue, if the line is outside the graph, you notice, okay, something is going on that we are not expecting. And we have this for this main dashboard, for the main categories. And if we want to know more, we can go to the specific dashboards. I will show you the gateway dashboards, but we have one for each dimension, right? So for the customer dimension, for the source IP dimension, for the route dimension. And here we can see all our gateways with a table where we can select what is interesting to us, and then we can select a specific gateway to investigate it. And then it looks like this, right? At the top left would be the gateway detail, if I hadn't blackened it out. And there we can see the traffic of this specific gateway to drill down into it. And then also some stuff that is specific to a gateway. So we collect actually a lot of data. For example, here, all the errors that we then model along at how often they happen per second. So to quickly identify some errors that are specific to this gateway or for a specific customer that we are interested in. We also have two other specific dashboards, the SIP replies and also platform errors, where we can analyze SIP replies or errors along each of these dimensions. So we can choose the gateway, we can choose the customer, like this, where I selected a specific gateway, and then I can see what is going on this gateway for the SIP replies. And exactly the same is possible for the platform errors.
And it's important in our parlance, is very clear to ourselves, but it's better to make it explicit, that I mean, we have the SIP replies, and some of them are cataloged like SIP errors from 400 to up. But we're not talking about that. We're speaking about what is specifically marked as platform errors by us. So, for example, we're getting an unexpected kind of reply in a situation. We mark it as an error and is the platform error.
Yes, and now what we're interested in is not only the visualization that we just saw, but we also want to get notified, right? If something is going on with our platform, or if we want to know how a specific customer is doing, for example. And the problem with simple alerts that I find is that if you decide on simple numbers, right? For example, CPS over 1,500, then you either get a lot of false positives, or it doesn't work, it simply doesn't work. So you have two options. Either you spend a lot of time engineering very complicated alert rules, where I do, okay, on this time of the day, for these days of the week, if the traffic is more than that, and also something else, I want to get a notification, but if not, then I don't want it, to try to minimize a bit the alerts that you get. But it still doesn't work so nicely because you have so many variables that can change along the day, along the week, that it's very hard to come up with good definition of what is an alert. So what we settled on was to have a definition of what is a normal traffic. And for those, we use the bands that you've already seen. You can use the band to visualize it. That's helpful when you're looking at the dashboard, but it's not so helpful when you're not looking at the dashboard. So we want to alert based on the bands, right? We use the same definition to visualize and also to alert. And to create these bands, there are a lot of options that may come to your mind. For example, you could do some kind of machine learning stuff where you feed it in the data, it computes a model of how it looks like, it feeds the data back, and you can visualize it, do alerting on it, and so on. That's a bit complicated. You need a separate service, you need to send it the data, you need to send the data back. You also can use vendor products. That was an option for us. And so we settled on doing everything in Prometheus. If you have already an observability stack, you will also have Prometheus running. And so it's a very low cost to implement it directly in Prometheus, have everything running, integrated in Grafana. And as a starting point, I found this open source project, PromQL Anomaly Detection Framework, that does exactly that. It has some recording rules, if you know the recording rules of Prometheus, that compute some statistical stuff about the metrics we are collecting. And it's actually built by the Grafana team, and they use it. If you pay for the hosted Grafana solution in the cloud, you get it with it, and so we knew that it was working. And the great thing about it is that if you change how the bands are computed, you can directly do it in Prometheus, reload it, and you can visualize it, test it, see if an alert works. The simple problem was that the rules are not made for telecom traffic, so they are basically for website traffic. So we kept the idea of having everything in Prometheus, and we rewrote the math to do the alerting, to do the bands. And if you're interested in the specific math, there is a slide further down where you can look at it. For the rest of us that are not so interested in the specific math, I have here a broad overview of how it works. You have the live signal of your metric. For example, right now your MOS is 4.2. And then you look back at 4 reference days at this specific time. So yesterday, 1 week before, and 1 week before, 1 day before, and after. The simple reason why we don't simply do 1 week before is that, for example, today is Monday, yesterday was a weekend, and if last week was unlucky and holiday, we would have 2 bad reference days. And so, like this, we can't have the possibility that we have 4 bad reference days. Then there's some self-weighting. If the look back is on a day that looks nothing like today, the weight gets down-weighted of that reference day to account for that it doesn't look like today. We then compute the drift, so in the days that we have as a reference, how much did that metric increase or decrease in the coming time frame? And with that, we combine it to calculate the bands with the live signal. So here a brief example, just to explain to you why it's no problem if you look back on a holiday. We have the 4 reference day, 1 day is a holiday, right? But as it doesn't look anything like today, the traffic of that holiday, it gets squashed, the weight that it gets. And so we have no problem even when we're looking back at the holiday. The benefits of this solution is that you don't have a holiday list that you have to like silence your alerts and keep track of when you want to fire alerts and when not, because it should be accounted into the bands. You don't need any extra tools. You're already running Prometheus, Grafana, so you can build it in Prometheus. And you can test it. I spent a lot of time testing different stuff, looking at if it would trigger when an alert is there, when an alert is not there. So you can play around with it also in an automated way by changing the rules, see how it behaves. This is the formula. For the ones that are interested, you will also be able to access the presentation to take a closer look at it. And here I wanted to show you some examples where it's zooming on these bands, right? So the traffic mainly starts at 8 in the morning on this specific platform. And so we can see that at the start, the spread of the band is very wide because it looks back at other days. It knows that the traffic starts there, and that it starts because we have a very, very, very low volume of calls. It can swing widely, right? And so the band accounts for that by being itself very wide. And then as the calls increase, the band gets very narrow. So if we had a significant drop in MOS, we would instantly get notified by that. And here you can also see the morning ramp up. So it knows that the calls start from around 8:30 to 9. And so there you can see that the band is already there because depending on the day, it starts at a little different hour. And there you can see that it accounts for previous days. And here we can see breaches, right? We have some sort of spikes. And these go outside the band and also don't look very natural. So you would get a notification depending on how you configure it if something like that happens. That is also something that you can yourself decide if you want to get notified by something like this or if the breach has to be even larger. And we'll talk about exactly that right now. So if we have these bands and the metrics go outside the bands, we have an anomaly, right? Something is not like it was last week or yesterday. But that doesn't mean that we want to have an alert, right? Some anomalies are maybe okay, other anomalies are not okay. And that is where your knowledge also as an expert in this field comes in, and you have to bake that in together with the bands to decide on if you want an alert or not. There are a lot of stuff that you can combine with the bands, right? You can say that it has to go outside the band by a significant amount to be an alert. You can also say that the traffic volume must be such and such. Or you can also say that the duration of the breach has to be prolonged to get a notification. Those are some of the ways you can create these alerts. And we ourselves use Grafana managed alerts. There are a lot of tools to do that. We decided on Grafana managed because the number of alerts that we use is not huge, and it scales no problem to a very big number of alerts. And so also here you don't choose another product that you have to maintain, you have to lifecycle and so on and so forth, but you have simply your Prometheus, your Grafana, and everything is built in. Grafana also offers the rules, silencing, routing, grouping, so all the basic functionalities that you may know from other tools, alerting tools. And you can simply give it an email or a webhook, and it will send your alerts right to where you want them. You can also do grouping. That's quite nice. So if you have a lot of gateways, let's say a couple of hundred of gateways, you group them together in a single alert, and you get notified like that. And then at the end, when you get the alerts, you have decided on how you want to be notified based on the breaches that you have. You can simply get the alert. It's always built in that it has the dashboard links to it. You can also add to that if you want some more links to see, get a look at the data. And then you can drill down by gateway, by customer, by route. As we saw it before, you can integrate it also with logs. Here we showed only metrics. But of course, you can also integrate it with logs and whatever you want to really drill down into what the problem is. That was it.
As you can see in the down row, we just, this morning, put the stuff, both the presentation and the dashboards, the Prometheus rules, all the stuff is in that. Okay.
Any questions? I got time for one question. Come on, I know you're out there. There we go.
You have ideas about automatic correlation between this metric to simplify this drill down procedure. For example, you have this spike on your metrics. You have alarm find what's going on, who doing this, which customer, or maybe there's few customers who starting to do something, and
yes.
everyone doing usually automatic manual drill down. Just go to other dimension, just by customer, and try to find which one doing this.
No, actually, it's a bit simpler than that. So you have all these specific dashboards, right? The gateway dashboard, the customer dashboard. So the alert would come directly from that specific customer that is experiencing this anomaly. So you would directly get to the dashboard of that customer and directly see all the information of that customer.
If you have threshold for this specific customer, but if you have like 5 customers who not reach it like every per customer, but in total you see the spike.
Yes, maybe I'm not fully understanding the question. So.
We also have similar statistics, and the question is like how to automate this drill down procedure. Automate, not to check manually.
Okay, so if you're basically on the main dashboard and you want to know, did I now understand it correctly? Yeah. So you see a spike on the main dashboard and you want to know which customers are there that are causing this spike.
Manual digging.
Perfect. So basically what you can do is you have the linking from the main dashboard to, for example, the gateway dashboard. And at the top, I didn't screenshot it. Actually, I did screenshot it here. You see all your current gateways, or for example, all your customer, and you can filter by it. So on the top, you see everyone, so you can see which ones are spiking. And so below, you can then select the single ones to drill down to it, all on the same dashboard.
Okay, that's all the questions we have time for. Let's give these gentlemen another round of applause. Well done, well done. Where's Vlad? Stop arguing. Come, present something. Liviu's laptop. Everyone's got a piece of Liviu's laptop.
Я, кстати, подключился через наушники свои, слушал, что дает микрофон, там треск просто. То есть у них, видимо...
Seriously, you gonna sit back there and laugh or help the man?
Или где-то контакт под уровнем. Это какой голос? Сможем посмотреть? Не видел еще 11. У вас 9, по-моему, был до этого, да?
Не, 6-й, кажется. 8-й. 6-й, по-моему. Или 10-й, 10-й, может быть.
Yeah, so my name is Vlad Paiu. I've been with OpenSIPS for a while now. Too much time. Today I'll be talking about just the OpenSIPS script observability and about what's new in OpenSIPS 4.0. So we're going to go about what we had before, traces, logs, metrics, statistics, stuff like that, and talk about how OpenTelemetry helps moving some things out in OpenSIPS 4.0. So what we had before, I guess we can start with homework. I guess most of us have used it for SIP trace collection, maybe log collection. It offers a bit limited observability on the SIP message processing time, and like you can infer that from the like the message timestamps when the invite came in, when the invite came out, so we can see, okay, this invite processing took, I don't know, 500 milliseconds, but it's a manual chore, and it doesn't really give a clear indication of what's the direct logic path the message took while processing. Many people are doing stuff like, okay, if this error happens, I'm going to say 503 service unavailable 1, and if this other error happens, it's 503 service unavailable 2, so I can see what went wrong straight in the SIP trace. But it's just awkward. Then, yeah, of course, obviously logs. Specifically, I want to mention the exact message threshold parameter, which gives you like a max number of microseconds that the processing is expected to take in the OpenSIPS script.
And anything that goes above that will just get OpenSIPS to logs and a bunch of warnings to your logging facility. And then you get like an overall length of the SIP message. In this case, it took almost a second, 900,000 microseconds, and then you get the stack trace and define most time-consuming OpenSIPS things. So over here, like, okay, just an example, RTP engine took 300 milliseconds to engage, then I did the raspberry, and so on. So in theory, you could set things like message threshold to 1, get alerted of all the SIP messages to syslog, and then the metrics to see like how much on average your SIP message processing is taking and what are the most time-consuming offenders. But it's not very great for errors and errors that randomly happen. You just can build some metrics out of it. And then, yeah, obviously, next is statistics interface. By default, we have a ton of, let's say, statistics exposed by various modules like TM, dialog, registrar, so on, where you are just offered these predefined statistics. You can also build your own, define your custom statistic, and just increment it as things happen. And then you can fetch it from the outside world via MI.
Keep the microphone.
Oh, sorry, yeah. And one thing that people, I guess, overlook is that statistics have support for time series as well, so they can build averages for you out of the box. So you can just define an average statistic, then, I don't know, let's say if you want to count your average PDD straight from within OpenSIPS, you can just, when you get the value in the on-reply route, you update the stat series of PDD with your specific call, calculate the PDD, and then from the outside world, you can just fetch this, you can just less minutes, PDD value that your OpenSIPS has. And a couple of other nice statistics to be aware of are the load statistics. So OpenSIPS has a bunch of processes going through and working through your SIP trace processing. And you can see how many of those processes are actually involved in doing the SIP work. It's a percentage-based statistic, so the worst it can be is 100%, where all of your SIPs workers are stuck in something most likely and can't keep up with your SIP processing. You want to see those values in the low tens to be comfortable that OpenSIPS is not choking while processing your SIP traffic. After you have all these statistics, well, where do you take them? I wasn't sure if I should even say SNMP, but I just put it here just for the sake of it. It's old, it's outdated, it requires lots of plumbing, but it's where things started. Then, yeah, Prometheus, you can use it to collect metrics and get alerted, exactly what Giovanni and Rocco were showing earlier. Basically, OpenSIPS produces statistics, then you expose them via Prometheus, and then you can graph them and get alerts in Grafana. The way you configure that in OpenSIPS is very simple. You just load the Prometheus module. You tell Prometheus what statistics you want exported to the Prometheus level, and then you can just start scraping them, and you can see how many active dialogues you have, how many, what's the load, and so on, whatever statistics you want to push. What was also nice, and added rather recently, I guess before, was the ability to push your own custom Prometheus values / statistics, because not everything in OpenSIPS is a statistic. Some things like the current CBS value, that's not a statistic, that's a rate limit, internally held value. How many calls a client has, that would be dial profiles. Again, not a statistic. I don't know, stuff like how many active RTP engines, RTP proxies do I have? If I usually have 5, and right now I just have 3 reachable, and yeah, again, that's maybe a metric you want to monitor and get alerted. So you can expose whatever custom Prometheus metrics you want from within the OpenSIPS script itself, and then go through the same flow of getting alerted and Grafana. So yeah, Prometheus focuses more on metrics. It answers questions like how much failures, how much good things are happening good for dashboards, alerting. But when something is wrong, it tells you that something is wrong. But why, what is wrong is your job at the end of the day to figure out. So this is where OpenTelemetry is trying to help towards getting more information out of OpenSIPS. So we have metrics, logs, protocol traces. We can see the behavior, but we don't really understand what happened inside OpenSIPS while it was processing the messages. So we don't know things like which route blocks actually got executed, which script logic branch was taken, how much time did I spend, I don't know, querying my various endpoints or doing my DB queries or talking with IoT, IMS, and so on. And when an error happened, like exactly what step was that error? You could gather all this information before, but it was a lot of manual work as somebody had to combine the logs, the traces, the metrics, and the time of the incident, and then correlate all of that and be able to say, yeah, this is the issue. So how OpenTelemetry is trying to help us, it's basically an open standard for observability. It offers a common way to generate and export all of these things that we need for troubleshooting. And it helps us observe that requests go through our multiple, let's say, services. It might be multiple OpenSIPs, it might be just one, it's up to you, but you can correlate between several systems in your architecture. It's obviously designed to work across different languages. We have support for OpenSIPS in C, but you can trace basically anything. And afterwards, after you collect all the data, it's fully decoupled from the storage visualization, so you can continue to use, let's say, Grafana in the same way you were using your Prometheus stack before. So a couple of, let's say, key concepts in OpenTelemetry is traces. It's the full processing of a request, let's say in general. In our use case of OpenSIPS, it's the full processing of a SIP request through OpenSIPS. A span is basically a single chunk of operation needed for the processing of that request. In OpenSIPS terms, we use routes. We dedicate specific logic in a specific OpenSIPS route, and a route becomes our span. Then the context, it carries across through all of the traces and spans that are related to the processing of the SIP message. And then to each individual span, we can attach attributes that can be, okay, where this message came from, when it started, how long it took. You're fully free to add whatever attributes here. And also things like logs get attached as events to the specific span, to the specific route that was took. So basically, in short, once a message, one trace, we get in with OpenTelemetry, and each route log becomes a span. Then attributes are attached to the span, and logs are events to each span. So the way it works is we have our, let's say, SIP endpoints, phones, carriers, whatever. They reach OpenSIPS, and every time you process some SIP message, you send the data over to your OpenTelemetry backend for error investigation, analysis, end-to-end visibility. And more specifically, you would probably want to use an OpenTelemetry collector and then send that over to Grafana for the temporal traces, maybe for metrics, logs, and yeah, just use Grafana, same way as we were using before. This purple layer in the middle here is the OpenTelemetry collector. Its purpose is to be basically the pipeline in the middle from the actual producer of the telemetry logs, which is OpenSIPS, and getting them towards your observability backend. So there's plenty of options to use here for OpenTelemetry collector. When OpenSIPS replicates traffic to it, it does it over OpenTelemetry protocol, TLP, which runs on top of HTTP. Usually the default port is 4218, and the default path is v1 traces. And the payload that is used in OTLP protocol is protobuf by default, so you can have like a full structured schema in there. And I'll go into the demo part, like how we can actually set this up and view things quickly. Grafana provides like a default package document there for the OpenTelemetry collector and then the full observability backend. So it's called looks good to hotel looks good to me, but actually it's hotel Logi Grafana Temple Mirror for the full stack observability. And we can quickly pass the 41.8 port for the OpenTelemetry collector listener and just start Grafana port 3000. Then the only thing that you need to configure in OpenSIPS is just load the OpenTelemetry module, say that you want to enable OpenTelemetry tracing. You can later disable this, toggle it on or off from the MI level. Then point your OpenSIPS to the OpenTelemetry collector, which in my case is just localhost 41.8. Then tell OpenTelemetry what logs do you want here. Any logs above this log level will automatically be attached as events to the spans, to the OpenSIPS routes, and how do you want to identify this OpenSIPS observability backend. In this case, just an edge proxy. So then you would, let's say, just let OpenSIPS start processing traffic. Usually the most intensive like SIP message processing are for registers and invites. So I'll just show one example for register, one example for invites. In my case, the register, when I get it in the main route, I just call my handle register route. In the handle register, I'm like simulating a slow API call. I'm just doing an async sleep to simulate that. When the 1 second sleep wraps up, I get called this resume sleep route, I log a message, I call, let's say, my business logic route, and if that errors, I just show another error here, I propagate the error, and I call save register. In my business logic, I just, again, simulate a failure. This time, previously we were simulating a long API call, now we're simulating a failure. I'm just returning -1 from this route, and I'm logging some message. And then in the save register, I'm just logging that I'm about to save it and saving it in the user location map. So what I usually got before in terms of logs, it was just this blob of text of logs when a new register was coming in. We can see the register came in at 11:16:15, then 11:16:16, the sleep wrapped up. I see the error that happened in my business logic, and then I still eventually ended up seeing the register. So in, I'm not sure how clear you can see this with the black background, but by default, once you configure this in OpenSIPS and have OpenSIPS export the telemetry data to Grafana, you can just start immediately searching. You're saying, what are my slow processing SIP messages? Or you can start filtering by specific call IDs, like I have there, where I filter by tag, span, and SIP call ID equals my call ID. And I can see at the bottom that I have a register request that took a second to process, and that's the trace ID that was generated for it. And then, as I was explaining, each route gets a span in OpenTelemetry. So basically, the top span is the OpenSIPS received a register request span. And then after OpenSIPS received that, the basic parsing that took, I don't know, 300 microseconds. Then the main route got called. From that main route, you can see it's further in and inside. I started my sleep. I resumed from my sleep, the sleep duration, I can see it's 1 second, and it's the biggest chunk of the OpenSIPS processing. And then I called my business logic. You can see that that one is has a red button banner on it. I'm automatically notified that some error happened there because I returned -1 from that route, and eventually I just saved my register. So if we take a look at each individual span, the most, let's say, the most information-heavy one is the topmost span, which describes the SIP message. The naming convention is for the top span is SIP method and whether it was a request or a reply or what type of OpenSIPS route I was processing at the time. So here it's called register request because it's an actual register and it had the request route. And we can see some, before expanding anything, we can see some basic attributes over there. We can see the OpenSIPS process that did the work. We can see how long it took overall in terms of microseconds. And we exported it. And the bulk of the data is under the span attributes. So if we go in the middle and expand on the span attributes, we took, there was no SIP semantic convention defined. The most similar one that was around was the HTTP semantic convention, so we kind of followed the HTTP semantic convention whenever it made sense. So we have attributes for which was the server that processed this request. It's 127.0.1.5060, which is my OpenSIPS. Where did it come from? It came from client port 5105. That was SIP, UDP. You can see the call ID in there, an attribute. You can see the CSEC, the type, it was a request, and you have the full SIP message payload inside as well, fully as an attribute, and a bunch of other things like what was the user agent, what was the request URI, just so you don't have to parse things in case you need more specific details. So yeah, pretty much everything related, describing the SIP messages and the span is in the topmost span. And then if we take a look deeper inside each individual span, like here I zoomed in on the resume sleep span, I can see that I entered the resume sleep from that part of the OpenSIPS config at line 200, so that was the, let's say, the natural flow of the request to the OpenSIPS script. I can see it took 1 second, and I have the 2 logs attached as events to this resume sleep span. And yeah, I can further see that child count is 2, so from this route I ended up calling 2 subsequent routes, my business logic route and my save register route. And if we look at the business logic route, that, if you remember, was just returning -1 simulating a failure, well, we can see that here. We can see that the status of this span is error, that's why it has that red check mark by default. We have the error type in there as the span attribute because the route then -1, we have the error route -1 over here. And we can see the error happened at line 201 of the OpenSIPS config, and this is the actual error log that happened. So with having all this data, you can imagine that you can just connect your Claude or whatever codex agent to your Grafana MCP. Just asking a question, what happened here? Why did this go wrong? Well, it went wrong because this route took 1 second to process, and you have an error in that OpenSIPS route. So that's what you have to optimize. Reduce your API call from 1 second to less, and take a look why that route is error. And for, let's say for invites, I have a similar example here. Basically, from the main route, I just, this method invite, I call it the handle calls route. And then I just look up my user, create a dialog called the relay route. From the relay route, I set my branch on reply failure callbacks routes, and I just send it out. And from the branch reply failure routes, I just log it. If we go back in Grafana and search for a SIP call ID that belongs to an invite call, you will have all these spans, different traces, sorry, for each individual processing that happened in OpenSIPS for your calls. So we got, if you go from the bottom up, the first one is when OpenSIPS received the invite, that's what we have there as invite request. Then what happened is OpenSIPS actually relayed the invite to the client and called the branch route. So we have another trace with invite branch. Then replies started coming in, probably a 100 reply and 183 reply. The 183 was followed by a track. Then another reply came in, most likely 200, okay, then ACK, and then a buy. And then for each individual processing, you can do the same as we did with register. We can see that, okay, the invite request came in, the route processing took this much milliseconds, this is how much my handle calls took, and I relayed. And I don't have any errors here, so that's the good part always. And for replies, again, the same convention is followed. We have an invite on reply route called within OpenSIPS, where OpenSIPS did some processing. In there, we just, the invite came and we called our handle net on reply route. So that was a basic processing here, or anything. And yeah, the on reply traces follow the similar, let's say, semantic convention as the requests traces. The only difference is that the route type will be on reply, and the response type will be the request. The SIP type will be response, and then we have a specific span attribute for the SIP code, so on, in this case. Yeah, so as future works, in this 4.0 we just added general profiling support and more, and also OpenTelemetry with consumer side for all the OpenSIPS information that we can provide in 4.0. Future work will be to add gRPC support as well. It's a bit better than OTLP or HTTP. Maybe authentication headers, maybe configurable retry batching timeout in case I don't know, the OpenTelemetry collector goes down. We want OpenSIPS to lock to replicate telemetry data. And I guess, yeah, more useful would be multiple exporters and conditional export targets if you want. Maybe you cannot afford to OpenTelemetry everything, but when you want to alert that there's an issue, you want to enable OpenTelemetry data just for that specific client that has an issue with carrier and so on. Because right now it's all or nothing. And aside from the control part, maybe we want also richer script data to be added there. Right now we have the message in the routes and logs we're missing, maybe ABP and script data in there just so we can better understand what happened with the processing, and support for some custom defined attributes if you need them. So this is all just future work. I'm almost at time, but yeah, the key here is that before OpenSIPS 4.0 we just had to do some manual inference to understand what was happening through the OpenSIPS script, and now we can just observe directly and do it from the moment it went into OpenSIPS and the moment it went out the network. And fortunately we don't have Shlomi Nitzan here from Voice Center. They were the ones that sponsored this work. I worked with them just to try to get a good fit for the OpenTelemetry and implement it how it makes sense. So yeah, that's all I had. If you have questions or ever.
We got time for one question. Who's it going to be? Well, well, well.
What's the performance impact of having it enabled?
It's a lot of data. So the message, and it's separated into multiple payloads, span attributes, and then each span, each route. It's a lot of data. Depends how much CPS you have, I guess. But we need to improve it in the following releases to allow for OpenTelemetry collector to go down, to enable it just for specific cases. So it's a good first step. But if you have 500 CPS, you're not going to be able to replicate 500 CPS.
Time for one more.
It's a very quick question. Is it available in OpenSIPS 4 only, or earlier versions as well?
4 only.
4.
Yeah.
Sorry.
Sorry. Welcome.
On that disappointing question, we're going to end that. Everybody give Vlad a round of applause. It's that time. It's lunchtime. Is everybody hungry? Yeah. We're skipping lunch. You got me for the next 20 minutes. Now, you got a 1 hour lunch break. Let's try to get back in here at 5 of. I'll start corralling you guys at about 10 of. Lunch is out here. Go ahead, you're dismissed. Oh, wait. I want to mention who sponsored lunch. The guys at 5'9". Thank you.
splitter because it's not working with the GMI splitter. It's not working.
Yeah, it was the good old times. People say that back then everything was way easier. It wasn't, but looking back, maybe it was because when we were deploying our first soft switches here, I mean, it was a huge scale for us, obviously, right? But the scenarios were pretty simple, right? So we had an invite and 180 to 200, maybe without some ping-ponging even UC. And once the RTP was flowing, we were all good, essentially, right? Obviously, there were voicemail scenarios and IVRs and a little bit of this and that, but in general, that was it back then. What didn't change, though, was these things. I call it the Excel sheets from hell. Who knows them? Nobody. Are you not testing? I think the last time I was here in Bucharest was around 10 years ago when I did my last software update on this particular soft switch personally. And I think we were done at 2 in the morning, and then for another 4 hours we ran through this kind of Excel sheets manually, picking up phones, blowing into phones, trying to see if you get two-way audio. And I think at 6 in the morning we took the first subway back home to the hotel. And funnily enough, it's still kind of like that. Maybe not, because you are obviously not doing that. But I know a lot of other people that are. Now, the problem is, it's not 2007 anymore, it's 2026. And it's not about the beep anymore either. And with the beep, I mean, it's not just about getting the audio flowing, right? So we set up OpenSIPS, we set up RTP engine, people do their calls, and once the RTP is there, and we have heard in the morning, once the MOS is a certain value, we are all good. The main problem nowadays is scenarios are getting way more complex, and in particular with voice AI. Now, the question whether audio is flowing is not the goal anymore, rather than it just becomes the foundation. And the foundation means it's all about what did the audio actually mean that is flowing, right? And that creates a lot of new challenges for us as kind of old school telco engineers. So in order to have a look at which kind of challenges we are nowadays approaching we do a little exercise and build an AI voice bot from scratch. Who implemented a voice bot by yourself already? Oh, quite a couple. Are they in production? 1, 2, yeah, very good. So you guys already probably know what it takes to get them from demo to production, and it's quite a bit. Just doing the demo, particularly nowadays with AI and agentic coding tools, it's pretty simple, right? So I tried it using PeerSIP as a SIP client, because in the end, you need to start with something, and being a SIP guy, taking a SIP client would be the obvious choice, obviously. And I don't know, who knows PeerSIP as a client? I've heard it today already. Quite a couple of people. Yeah, so super modular, super lightweight client, a very nice code base, extremely adaptable, and you can just plug modules in there. And it starts with providing some kind of SIP and RTP core, and then you have all kind of feature modules, but you also have an audio chain that you can use and that you can extend. And one of them is audio resampler. And why an audio resampler? Because when we are talking AI, it usually goes from speech to text to some LLM, and then back to text to speech. And those kind of elements usually need 16K BCM, typically. And this is what PeerSIP actually provides. What I tried is just implementing a voice AI module. And this voice AI module, I just approached it very naively, saying, okay, look, when on the top left we have OpenAI, for instance, but Google Gemini works pretty much the same way. You need to create a WebSocket connection, and then you need to send meta information over there, like prompting it. Prompting it, and provide some configuration.
And then you send audio over there, and you receive audio back, and you receive all kind of meta events back, and then you can feed it from the SIP side into your OpenAI and back. It's really pretty simple, so you can do it like in a couple of days probably. Now, what you need, and this is just to give you a quick intro, in order to build something like that, is you need to get like an initial session burn-in, so you need to create a session with OpenAI. You send an API request over there saying, look, I want to have GPT-4o real-time preview, for instance. It expires after an hour. And your instructions, like your prompt is going to be, you are a helpful assistant, which is not super helpful in production, obviously, but you get the point, right? You say, okay, BCM16 is the audio format. You have some turn detection, voice activity detection that you can configure in different kind of ways, by the way. Some, like OpenAI already provide semantic detections that they not only check on the audio threshold rather than try to understand, okay, are you done with your sentence? And then they basically start talking. Now, the main problem is when you deploy a voice bot, you don't want to have just a talking FAQ, right? You just don't want to provide all the information you have in the prompt, rather than providing your bot with tool calling capabilities. And actually with OpenAI and Gemini, it's super easy. You just send via WebSocket a session update to your system and just instruct it to say, look, you're gonna have a tool available which is called hang up call, right? And the description would be it ends the call, so the AI knows basically what to do. Which is interesting, right? Because you want to have your bot to hang up calls. Why? We're gonna see that later. But also you wanna have them to do API calls, because when I call my bot and ask them for doing something, I want the bot to be able to call my CRM, for instance, and fetch data based on that. Or I want to do the bot to do like a calendar booking, or I want them to, you know, store some information somewhere in some web service, right? Now, that's great for a demo, and essentially it would work, and it does work, but would it work in production? We're gonna have a quick look. So we're gonna look at the 9 different dimensions, starting from the very bottom, right, which is the SIP performance. This is where we typically live, right? So we know about this thing. We know about all this plumbing. We have all created some kind of voice applications, and the voice bot is nothing different than that. So everyone who has ever used like OpenSIPS to do some load balancing for PBX instances or something like that knows this. So there are some couple of design decisions that you need to take. Am I going to use like a FreeSWITCH or something, or BSIP in my example, directly and just put all my bot channels there and let them communicate with OpenAI? Or am I going to put like OpenSIPS in front and use that as a load balancer and then have each and every bot being like a single bot in my Kubernetes or a Docker instance or something like that? All of that has like pros and cons, as you all know, so it's, again, nothing different to a normal voice application. And the only thing is, all of these kind of things need to handle basic SIP functionality. And this is, when you look at who the people and the companies are that are approaching voice AI, there are 2 different kind of types. One of them is the ones that come from the telecom side, and they know like all the SIP technology. They know what it takes to create a proper call, and then they put AI on top as another kind of media generation engine. And then there are the AI companies coming from like this Alexa and Siri style services, right? And now they figure, okay, voice AI in terms of telephony is a thing, and they start plumbing telephony on the bottom of the product, of the existing product, and they are in for quite some surprises. Now, when we talk about SIP, it's all about like re-invites, handling session timers that you probably don't even recognize when you just test it manually for 2 minutes, right? You never get a session timer update, usually, right? Or having a customer to put the call on hold and then resumes it without the bot actually shitting the bed. And that's actually a thing with those kind of applications when you are going and approaching that a bit too naively. And the other thing is like measuring metrics. We have heard that in the morning already, right? Post-dial delay is a thing. SIP errors that you need to handle are a thing. Yeah, that's one thing to acknowledge and to handle on the SIP layer. Having that just in our bare SIP, it might even work because bare SIP is just a very good foundation, but it won't just scale. Now, dimension number 2. So we got the signaling up and running, we got the codec negotiation and so on up and running. We're looking at RTP performance. So now the voice starts flowing. What does that mean? The problem is AI, I mean, it is sensitive to jitter, loss, and RTT, like even more than a human being, right? And the funny thing is, we spent 20 years or so to optimize on the RTP layer for the reality that the internet brings, like the packet loss and stuff like that. We created Opus. We have all this forward error correction and all this kind of mechanism to make sure that we get in all kind of circumstances the audio working perfectly fine over all kind of conditions. And now we just created a WebSocket connection in our pair SIP and have a TCP connection over to OpenAI and start sending 200 millisecond chunks of audio encoded in base 64 over the internet to OpenAI. And you can probably imagine that this is not gonna work out well. I mean, maybe for a demo, maybe for your first customers, but at some point this will create a huge problem. And that is also where people are then in for a surprise. I mean, if you look at OpenAI, they have a second option to do that. WebRTC, we all know that, right? Yeah. Now, you can imagine what happens if a naive AI developer starts seeing the first WebRTC SDP offer answer for the first time. That's going to be a challenge. There are your SIP RTP element. You just have an input file. You can, on the other side, record the received input. And just use PES, Copolka, or Viscore, or any other kind of full reference metric. All of them are available for quite a while. And just get a MOS calculation out of that. Now, with bots, that's not so easy anymore because you're just not going to have a reference file. You're going to send something to the bot, and the bot is going to answer whatever, right? Good thing is that there are quite some interesting research projects going on. One of them being from Microsoft Research, who created with an Austrian university AI models that are trained on hundreds of thousands of hours of voice. And they're called Distill MOS and XSLR MOS. And you can just feed them one wave and you will get a MOS value back. And you can run them on your own Hetzner or Servers.com server with a GPU, really cheap, works extremely well. All right, so audio quality, hopefully granted. Now about the audio performance. Everyone in the AI industry, and particularly in voice AI, knows about this, what I call awkward silence matrix, time to first audio and turn-based response. Now, the thing is that, at least in my LinkedIn bubble, I see week after week after week new announcements saying, we got all of that covered in like 200 milliseconds response time, and it's like the natural audio experience that you get with this new kind of model. I still yet have to see this in the wild, to be honest, right? Because when I get something with the testing that we are doing, somewhere below a second, I'm already satisfied usually. Because latency, it's accumulating, right? You have the RTP round trip time, and then you have your hops from speech to text to the LLM to the text to speech and then back, or maybe you even have a speech to speech model, but they are all just not near the 200 milliseconds. The problem is that the response times usually they vary quite a bit, depending on what you're doing, because when you do this kind of manual testing and you talk to a bot for the first time, you say like, "Hi, I'm Andreas, can you tell me my, I don't know, hotel reservation?" Which is actually pretty short. Then a lot of things are going on in the background of this bot, right? So the bot is probably, hopefully, not gonna have my data hard-coded in a prompt rather than in some ERP, CRM, whatever system, booking system. So they're gonna do an API call and that is gonna just accumulate on top of my response times, obviously. Now, some bots are clever, right? They're doing some kind of ambient noise in the background. You might have heard that, or some clickety-click with the keyboard, which actually helps to just get the impression that something is going on. The worst thing that can happen is there's nothing, and you're like, hello? And then in that exact moment, the bot is gonna answer, and then you have the barge in things, which I'm not even mentioning here, so that's gonna be a problem. The other problem is context pollution, right? If I just say yes to a question, that's one thing. If I start reading them like a book, then the model is gonna start to accumulate all of this information, and they just need, you know, quite some time to come back with a response. So turn-based is not turn-based. It really depends on the context. All right, audio stability is the next one, where sometimes LLMs get kind of an identity crisis, because when I call my bank, for instance, and want to, you know, check the balance and I'm talking English, then Bogdan is already getting impatient in the background and shouting something, and I don't know what it means. I'm not talking Romanian. And the bot is saying something back, right? And the problem is that it happens even if you prompt it to not do it, right? The next problem is that these kind of bots, or the LLMs, they are not deterministic. So however well you prompt your bot, there is a chance that it's just not gonna do what you're supposed to do or what you want them to do, right? So there are other things that you can take into account for language selection. I wouldn't even know, probably using an LLM model that just talks English, right? But if you tell OpenAI to say, hey, it's just English, and you just ask often enough, at some point it will switch. Right? All right, audio correctness. Another interesting thing, when we from Sipfront do the testing, we usually approach bots from an end-to-end perspective. So more often than not, we are not getting metrics like a word error rate, for instance, from the speech to text, right? But you don't necessarily have to, because I don't really mind whether the LLM or actually the speech-to-text model in front of that or baked into the LLM understands each and every word of what I'm saying. For me, it's mostly important that it understands the intent, right? So I want to buy something, for instance, rather than exactly knowing I said yes or yeah or whatever, right? The only problem is there are some things that you need to do properly and the model needs to understand properly, which is names and IDs and other identifiers. And people usually approach this by trying to do different kind of, or chaining different kind of bots or models, right? Some rule-based models that are just there for the authentication, that they know exactly, and they only know my name and my ID and whatever, and they can't answer a recipe of an Apfelstrudel or something like that, right? They just are there saying, okay, who are you? I'm saying my name, they try to do the lookup, and if it doesn't match, then they say, I couldn't understand you, like, or I can't help you, or whatever. What's important there is also like how many turns a bot actually needs to be successful, and that's a metric that's pretty interesting. Usually you can only, at least end-to-end, measure that by measuring also the tool calling, or maybe the outcome by just saying, okay, I'm Andreas, and I mumble something in there, whether the model behind that is gonna just accept that and interpret it the way they want, or they come back and say, I didn't get that, really, can you repeat that? That's the question. Usually LLMs are super, how you call it, obedient. Like they just do whatever you want them to do, and they rather do something than telling you they didn't understand it or that they might be wrong. The other thing is, I mean, there are things that are to be tested there, because here we just have like different kind of English accents, and when I talk to the bot and I need to have kind of like a correct answer, then in that particular case, for instance, Indian English was obviously not part or not that much part of the training materials, so they are traditionally rather bad, like in this particular example. Right? And you have to have an eye on that, like whether it's going to be English or certain accents, or whether it's be a geographic region of your country. That's something to consider. Content security is another one. So we're talking about prompt injections and jailbreaking, because we are actually exposing like the AI interface to our users in voice. So it's super easy to tell them a lot of things. And there's actually a paper, 5 months old or something, so things might have changed. But what it's about is using poetry as a universal single-turn jailbreak mechanism. So if you are creative and tell your LLM, and that applies to voice AI as well, a rhyme or a poetry, chances are, like with at least DeepSeek and other ones, I mean, I took the cut somewhere, but OpenAI is also there above 50%, that chances, at least 4 months ago, chances were that you were able to get a jailbreak over 65% of the time by just, rhyming to your model. And you can prompt your way around that if you want or can or try, but that's just a thing to keep an eye on, right? All right, cost protection. We in telco know that fraud is a thing. I'm not sure if you also have seen these kind of messages lately that people were posting on LinkedIn. Hey, I just launched my voice bot over the weekend, and on Monday morning I got a $20,000 bill from OpenAI. Why? Because somebody just got funny, maybe it was vicious or something, and just started to call my number because it's exposed via SIP, and they just keep talking, right? And if you look at like the cost calculation, if you're buying directly at OpenAI, it's around 5 cents per minute. When you do a 1-to-1 talk ratio, you only need 140 concurrent calls for 48 hours to get 20K. And depending on how big your call center is, it might even keep you under the radar, because there's no person there saying, hey, I have a guy talking to me since hours or calling me again and again and again and always saying stupid things, and I'm just hanging up on them. The AI will just talk to them, right? And I mean, you can try with time capping, for instance, saying, okay, just after an hour, whatever happens, I'm gonna end the call. Or doing turn capping, so if you figure that after like 10 different turns, you're running in circles and always talk about the same thing, you end that. But that doesn't help you either, because the guys are just gonna call you again with the robocalls. So you need fraud detection, and you have them in your telco systems usually, right? If you have malicious calls calling you like 50 times per day, I hope there are mechanisms in place that you can actually flag them. And the last dimension is actually regulatory compliance. We are in the EU after all. And there are a couple of regulatory things that are relevant for that, which are not always on the radar, not even from the voice AI vendors out there. So the one that is going to be in place in August is going to be the AI Act. Actually, it's been in place since 2 years, but now there are more stronger regulations. The good thing is that not in all countries the institutions are there yet that you can actually complain or file a complaint, right? But it doesn't keep you from adhering to the rules. So one of them, the one that is most obvious, everybody knows about, is transparency and disclosure. So usually have to say something like, hi, I'm Becky, your digital assistant. Whether you bake that into your voice bot prompt and don't let your user override it, or you do, I don't know, right? We have talked to voice bot vendors who say, well, you put it in your prompt, if the user just doesn't want it there, they just remove it, it's not even allowed, right? You have to disclose that. Also, there are things like GDPR, and since like 10 years or 15 years you have in hotlines this thing where you need consent for recordings. That's an interesting one, because you need to say yes, for instance, if you're okay with having a call recorded for quality reasons or whatever. Now with voice AI, each of the cars needs to be transcribed, usually one way or the other, right? So there is a wave there is even text there, is it stored somewhere? You can or are only allowed to do that if the user consents to that. Whether you can work around that technically, that's to be checked. And the other thing is I would like to talk to a human. So in the AI Act, you have human oversight and the right to talk to a human. So if you talk to your bot and say, hey, I actually want to be transferred to a person, your bot needs to do that. So at least there, you have to have something like a transfer mechanism in your bot that you fail over or fall over to a human being. And somewhere between dimension like 3 or 4 and 9, we actually stopped being VoIP engineers and started babysitting our AI, right? We've heard that already before today. And that's gonna be like a challenge because it's not gonna use less people, probably, right? You probably need more people for that, not VoIP engineers, but QA people. And the main problem is LLMs, as I said, they are not deterministic, so you just can't manually test your way out of this. And this is why we at Sipfront are also there for the AI part. The AI told me when I was asking, like, okay, give me like a catchy title for this slide, it said, automate or die. I don't want to put it like that, rather than automate and succeed. So I would say it's funny to talk to your bot 5 times, 10 times, 15 times in test cores, but at some point it really gets tired and you need an automation solution for that. Thank you very much.
Thank you, Andreas. We have time for one quick question. Okay. One.
I think how do you feel about it? About my opinion. I think the question to ask the customer if he's okay with having the call recorded is already in violation of the AI Act.
Yes,
so you could
if
probably
you're using
say
a bot
press 1 for yes or 2 for no, but just say yes or no is probably already not allowed.
Yeah, needs to be checked. We did a session on that last week, a webinar, which you can find on our website, which is only in German, unfortunately, with a lawyer to look at those things, and it's complicated, let's put it that way. Thank you.
Okay, thank you. So now, next.
Okay, so we've seen some talks here. People have been using AI a lot to troubleshoot. By the way, Flavio, that was really cool. What I wanted to do was kind of approach this from the perspective that today we have a room full of people that have had experience with OpenSIPS, but there's many rooms of people that are out there that are afraid to have an experience with OpenSIPS because we all know it's a hell of a learning curve. Now AI has bridged that, obviously, and the way I'm kind of looking out there is that like people are just like, you know, going crazy typing, you know, not really structured. They're just asking questions and hoping for the best. And if they fill enough context in there, they might get something that actually falls in line with what they're looking for. So what I figured was, hey, let's build an MCP that everybody can use, connect it to whichever ID that they use or whatever LLM interface that they use, and at the very least, protect us from having to remember all this stuff. So the biggest reason why, it hasn't been the runtime, it's been keeping all this knowledge in your head. I mean, my brain hurts when I get done working with a config file and a simple edit. And really, as professionals moving forward in the age of AI, we shouldn't be responsible for keeping this info in our heads. We should have something that's able to check what's in our heads, but also supplement it. So, like really, anybody there might be 3 people in the world right now that have seen an upgrade from like 1.11 up to where we're at today. And you know, that's not a lot of people to really maintain that knowledge. So again, what we wanted to do was go back at least to like something like 2.4, and then also offer like tools inside the MCP server to be able to do a migration path. And again, think about it, like, where are you, where are you pulling this information from? Like you're going, you're searching, you're checking forums, you might be on the OpenSIPS mailing list and asking. You might know one of the developers and like hit them at like 3 o'clock in the morning when like in another 2 hours you got to go into production. So we didn't build this because AI is the answer. Really, tooling is the answer, and I think you've seen that already with some of the AI interactions we've seen in some of the talks so far. But the LLM is just the first interface. It's honest enough to ask, you know, which scenario is this before it writes a line. And by providing this background with the MCP server, you're giving it everything it needs to also efficiently not eat your tokens. Every rule in the engine is data. It's not a model weight. And look, if we got something wrong, it's a simple one-line PR. We fix it. This should be something for all of us to add to and benefit from. And like I said, we hope that this becomes, it's not really a product, it's not a moat, it's really a shared toolbox. We plan to continue patching it, you know, as versions are released. I will say that I dared to like try and breach into 4.0, and seeing that Vlad was telling me Bogdan was still releasing stuff as of Thursday of last week, I was thinking, you know what, let's leave that for, we'll put the placeholder there, but we'll leave that when all of the resources for 4 are out, we'll come back and just do an update. But look, a new operator can be productive on day 1, not month 3. That learning curve. Think about the OpenSIPS boot camps, if any of you have ever like gone through that from the beginning. Like, by the way, when Flavio was saying that he wrote the book on OpenSIR and like the next week he had to change it to OpenSIPS, I was supposed to get, like a certification for OpenSIR, and I was told that that was not available anymore, and I would be the first person to be the first certified professional on OpenSIPS. The first victim, yes. The first person that finished his test and didn't fail. But you know, it's got a rich history, and we really wanted to make sure that a lot of that was caught, as much of it as is still relative, let's say. So the runtime's excellent, the docs are solid. Really what's been missing is a way to put our reflexes into something we can all share, audit, and improve together. And look, it's an Apache 2.0, so look, bring a scenario, leave it with a tool. Obviously, we know OpenSIPS is one of the best proxies on the planet, the best proxy on the planet. But the cost that we pay for that power is operational. We pay it with our memory. Basically what I've been talking about since I started up here. You know, things like which modules pull which dependencies on which version, the mod parameter that's the right one for this specific deployment shape, whether Children 8 survives 500 CPS with TLS and NAT. These are all scenarios that we've all been, you know, up till like 2 a.m. in the morning trying to figure out. And the link check we would have caught on a Tuesday with our coffee, but we waited. It's not whether we know it all. The question really is, do we need to carry it anymore? And again, with AI, that's really becoming the point. Like, we don't have to carry it anymore. So this was meant to basically be pulled in to your workspace. You light up the MCP server, and now this is kind of like a natural language interface. So you could say, hey, give me a class 4 SBC that can handle 500 CPS with TLS, anti-flood, and HA across 2 nodes. Who's tried to build that configuration file or something similar? Tell me how long it took you. Certainly not minutes, folks. And even if this was a day, it still would be an advantage. So one LLM tool call, the engine renders 187 lines of config, modules are grouped, and you get core SIP, these are your modules, you get the anti-flood, TLS, it's all generated, lint cleaned, validated against OpenSIPS C, and ready to be deployed. So this is kind of the flow. Your plain English goes into the LLM, it picks the scenario or template that's closest to what you want, it begins to render. When it's done, it checks it to validate it against the OpenSIPS C. Then we run the lint test, and we're pretty much deployed, ready to go. Again, plain English, validated, audited out. Every command in here has an audit link to it. So to start, we did pretty much the 25 scenarios that everybody uses OpenSIPS for. Like, I don't think there's many more. There are a few that were kind of shadowed, but as new scenarios come up with you, our hope is that you will bring it to our attention, bring it in here. Let's keep adding to these and make it to a point where like everybody knows how to do everything. These are based on Jinja 2 templates with parameter schema, and it gives the LLM the ability to build it in one PR. So why MCP, not just another CLI? Well, CLI answers one question per command, right? And here you are constantly like progressing. This gives the LLM, more of like a RAG ability. You can continue on. You can ask it questions like, which scenario fits my deployment? Will this mod parameter that I'm trying to use still work after an upgrade? Is it safe to deploy in a public IP today? I mean, the security checks that are in here are actually really useful from the perspective that if you are asleep at the wheel and you're trying to get something done fast, it could prevent quite a devastating deployment. And at every step, all the calls they're a deterministic tool. They're producing machine-checked answers. It's not just a guess. It's not just a hallucination. So how does this stay trustworthy? Well, again, the LLM is not writing your code. It's not writing your config. It's working off of some of the base templates. It's working off the knowledge that has been put into the MCP server from years of documentation, years of examples being out there. So really, it's just ask, plan, run, and decide. These are pure Python tools. The same input is always going to produce the same output every time. It's an orchestrator and not an author. So questions that you're asking yourself right now. Will the LLM hallucinate a broken config into my production box? Anybody that has played with an LLM and trying to build configs, just off the fly, I'm sure you're not putting it into production, but it's produced some unexpected results for you. Again, the configuration engine is deterministic Python. The LLM picks which engine call to make, and every output runs through linting. And at the end, the OpenSIPS binary path, if it's available, in your project, you just need to check it before you do anything else. Things like credentials, dial plan, subscriber DB, it sets to default only. There is a flag in there that lets you, put it into admin mode. And again, depending on what your use case is, you might not need it, you might. But everything is structured in the audit log. So don't necessarily worry about it going off the rails and not knowing what happened. You're most likely going to have some type of history sitting there. So what if it picks the wrong scenario or the wrong parameters? The engine rejects unknown scenarios and validates required parameters before a byte is rendered. That's the beauty of having an MCP in line with what you're building. The plan is basically show you the config written, let you approve and do your deployment. So why should you trust this more than Vim in 15 years of reflexes? You shouldn't. It's not that you need to trust it more, it's that you should trust it to do the boring stuff. For all of the people that are professionals in here and have been working with OpenSIPS, we all know there's a lot of boring stuff. Changing, for instance, APP names across like an entire config. These types of things can be done very easily now. So the audit explain functions in here. It's obviously got pretty much every single function, module, transformation from 2.4 all the way up to 3.6. So by version, by available modules and functions in those, you're getting a full description and also a link back to where you can find it online. So like I said, modules, mod parameters, functions, pseudo variables, transformations, MI commands, globals, all of it's in there. And some examples of what the audit through the linting does. It's got some really hard checks, like modules won't load without their dependencies. It's going to check, your proto, if you've got all the configuration for that. I mean, basically everything that you could pretty much ask for as a check, just to make sure that you haven't fat-fingered or fumbled something. And all of the findings ship with a suggestion. So it's not just an error, it gives you a little bit of like background as to why your error is coming up. Some of this is a little outreach, a little far-reaching, let's say, but if you want to have some just basic like tuning parameters, get an idea of what it's going to take to fulfill a certain CPS or number of registrations held, TLS, these types of things, you basically can ask it to tune. And when it produces the output, it's going to tell you why. So what does this look like at your desk? When you're actually running it, like, what is that experience? Initially, I didn't think we were going to have really good internet, so I wrote a Python script that would just kind of play through some of these scenarios. And I didn't want to sit here and wait while the LLM actually produced the output for these scenarios, so what I did is I went ahead and preloaded. Did I get to that yet? No, but I'm not there yet. So I'm ahead of myself. I apologize. So let's say day one, you are new or you just inherit somebody's OpenSIPS config and it's like all over the place. And you want to figure some stuff out about it. Well, there's the tools here that'll do that. It'll actually, again, match it up as close as it can to a base template and then work its way back through that with you. If you're wondering why you're getting certain errors, I mean, obviously, again, we had the tool sets that we were looking at the errors from the perspective of hunting them down, but maybe the first place you go is to your config file. Check to see if something in there might be producing the error, and this is a great tool to use to see if there might be something that's not as it should be. Let's say that you want to actually do some of the real-time like configuration. All of that is in there as well. It'll give you, advised output for whatever you want, basically. And it also gives you the ability to roll back. So it's going to prepare you from the position of doing something and being able to get yourself out of it as well. How am I doing on time? Let's say you want to stand up an Acme tenant, and you've already got a multi-tenant proxy running, and you want to register a new SIP domain, or you want to create a bulk list of subscribers. All of these tools are here for you to be able to do that. Again, there's different ways of doing this. This is just, again, if you're playing, it's a scenario you want to build very quick for like a test or something. It's really easy to do. So I was saying before that there is some built-in security auditing. Again, this is not by any means, you know, completely something you should trust, but it's going to expel all the basics. Again, hopefully this evolves. People find new ways of doing, you know, security audits. There's certain things that are coming up that we all become aware of. Sandro tells us about something that we all have to be like aware of. Hopefully the idea is that this will grow again. Like we'll have a full security audit list of what it takes to protect ourselves. One of the nice things that we had time to do with this also was not only output config files, but also output at least your base like Prometheus and Grafana dashboards and monitoring. So if you go ahead and run a scenario, it'll give you a Docker compose, it'll give you everything you need to basically stand up, you know, the Prometheus and the Grafana. Again, this is not very in-depth, this is very surface level. It's meant for you to be able to get an idea of what you want. And again, through some prompting and through some modifying of what's here, you can actually get it to do exactly what you want. I spoke early on that it does track migration from 2.4 all the way up to 3.6. And again, when 4.0 is out there, it's stabilized, we're going to be adding that so that it'll be a full migration path up to 4. But pretty much, you give it a file that starts with a config file that's in 2.4, you could say, hey, bring me to 3.2. It's going to bring you there step by step. Another nice feature that was added here, actually this wasn't planned at all, the LLM pretty much did this, but it does give you a path to move from Kamayo configurations into OpenSIPS because they both share the same root. There are some tricky things that don't make it, you know, pretty much obvious, but this will assist you with if you are looking to do these types of transformations and moving from a Kamayo config to an OpenSIPS config. You can also use this to check Kamayo configs. It is aware of like, you know, what the structure is there as well. There's 12 real-world coverage examples in the project. You can access those. You can see at the bottom here. We'll actually mention it at the end. It is up right now. It is capable of being like downloaded and played with. But there's full regression suite in it as well. So if something breaks, you're going to get an idea of why. So this is the part where I was saying that I had the live demos and I had prepared everything. So I'm going to flip over to my IDE. So for instance, using the CFG explain 3 things in order: the load balancer list, the MI command, and the RU pseudo variable in the dialog mode mod parameters. Using the MCP server, you could see that it's able to immediately explain to you the answers to your questions. Let's say that you're playing with a config and you're trying to tune for a specific type of number of CPS, concurrent calls, this type of things, if you're going to be using TLS. You can ask it some questions like this, and basically it'll give you a small snippet to continually paste over and try. Build a class for SBC. This is what the example I was giving you guys before. As you can see, it gives you the full deployment information. It gives you the full config file. As I'm going from bottom to top. But you can see it's extensive. It's not just a template. And again, you can tune it. You can tell it specific to what your scenario is, and it'll work from here towards where your goal is. Let's say we wanted it to review a WebRTC gateway file. It has the capabilities of being able to look at your code, look at what you got in there, and immediately start fleshing out things that are critical. So in the case of this example, it knows that the invite has no authentication, and it's told fraud waiting to happen. There's no ACL on your MI, listening on your MI port. And it also gives you some ideas of how to fix. Again, extensively, how much you use it as it learns more about your specific configuration and the way that you're using it, obviously it will continue to enhance itself. So these were the demos I just showed you. I might have not gotten all of them, but I'm a little pressed on time here, so I'm finishing up. Just remember, every rule is data. It's not magic. So if we missed a rename, again, it's a one-line PR. It's not archaeology. The system is almost kind of self-maintaining while we work with it, while we add to it. Again, we have a very good foundation of documentation, all of the information available at the current time. So where does the operator knowledge live? These files are basically the tools that are being used by the project. And again, you've got 215 modules, 120 functions, 64 transformations, 61 pseudo variables. Those obviously augmenting based on which version you're sitting in. But it's auditable, patchable, but it's not a black box. So why this matters? Again, OpenSIPS is the best. The runtime's superb, the documentation is solid, we have an amazing and vibrant community, but the barrier between an operator and the correct OpenSIPS config has always been the authoring experience. And hopefully with this project, we just removed it. So if you want to get involved, it's up on the OpenSIPS GitHub. It's available now. You can pull it, start running it, start playing with it. At any time during the rest of the conference, feel free to reach out to me. Ask me any questions and let me know about how you played with it. That's it.
Thank you, Alex.
It's not what?
It's slowly uploading.
Oh, it's still private, right? Razvan, you said you would help me. It's private. You opened a private repo. Razvan wanted to keep it to himself.
Yeah, all for himself. Okay, thank you, Alex. That's really cool. I would like to give it a try to see how it works.
I could see that in your eyes.
Yeah. To see what it can do.
Do we have time for questions?
Yeah, we can take one question.
Okay. Here comes the bombing attack.
No, it's not that deep. Actually, I just have one question. You said it's learning over time about your scenarios. So is there some local storage about your previous conversations, or is it storing snippets locally, or how does it do it?
So there are skills and there are workflows in here as well in the package. It's a lot more extensive than what I've actually put up here. I only touched on, really the config engine itself. The idea obviously is if you're working with an LLM, let's say Claude Code or something like this, it's naturally learning, right? As you work with it, it's got memories. You just want to, if you're, how can I put this? If you're a really good prompter, like you've already got rules, you've already got stuff in your Claude MD that is going to build these memories. It's going to let you, it'll recognize. Of the most normal or most used scenarios. Those are going to continue to change. There's a lot of IMS stuff. And again, the reason that it was more shadowed is that it's not really complete right now. There's still a lot of like progress and a lot of changes that are going on. So if you come up with scenarios.
That means pull requests are welcome.
That's right. I'm actually a maintainer. Razvan took care of that. Good?
So we are updating existing scenarios, we're uploading new scenarios.
Correct. And again, give it your config file. Like if that's the first thing that you do, just pull your config file, put it in there, make sure the MCP is wired to your LLM, and just ask it, hey, tell me everything about this. Tell me why I suck. Okay, thanks again, guys.
Thank you, Alex. Okay, next we have Ihor Olkowski from CERN. And yeah, one of the old nemesis, IPv4 and IPv6 deployments, a dual stack. So let's hear it.
Yeah, hello. Just, it's randomly turning off. Oh, it's back. Okay, so I'll start with basic. So hello, for those who don't know me, so my name is Igor, I'm originally from Kiev and I'm working with VoIP quite a long, means for too long, I guess, and that's basically it. So the agenda, but I think I will skip it just not to keep the time a lot before the coffee break. So just a small thing what CERN is about, for those who don't know, biggest physical lab in the world and on its way to build a new collider. So now we're having the collider 27 kilometers, we're gonna have the around, I think, 100. So for those who know the geography of the place, it's gonna be from Geneva to Annecy. So if somebody know like the local area. And also just some glimpse about like what's actually interesting is happening there. So first one is actually the first in the world transport of antimatter. Right now just in the campus. But as I know, it's going to be transported to the Germany for some studies for the institute. And the question that I have here, basically, it's when you're passing the customs, usually you're paying taxes on the matter, so should we get a refund on antimatter? The next one is actually, I don't know if you know this highly precision time protocol called White Rabbit, which is not your like usual NTP, and it's used like, just put it's 10 speak a second, and now it's being tested to use the same fiber with the quantum entanglement particles. So why do you want to have this type of precision? It's actually, you see this Atacama array, telescope array, but they are close not only because they want to be close, because they are feeling lonely, because the question of synchronization between them. So with this type of synchronization, we can build sort of like same telescope, but on the different side of the Earth. So actually this one is compensating the Earth rotation, so this type of precision. And the lady on the photo is actually my friend, and she is actually working in the NUP, in the basement of our building, with the putting the quantum entanglement particles into this fiber of the White Rabbit. So that's just a small glimpse of what. So, as I said, as I wrote somewhere, so some tech from '98, so I'm going to be talking about the retro tech. And one of the, let's say, technology that was introduced also in '98, it's actually IPv6. So it's already that old. So, and yes, OpenSSL, what's for me funny now, because it's, I think, doesn't have SSL now, it's only TLS. So, and to put like what kind of problems I'm trying to solve, just to give you a bit of context. So that's CERN telephony scheme, quite simple. So we have an endpoint, we have a SIP proxy registrar, and basically that's it. So nothing, something secret, nothing, something complex. But the complex, what is? It's actually geography. Geography in a sense of how many networks do we have there. So this is an overall plan. So with in the green circles, we have two main sites. The red thick line is the border between France and Switzerland. And here, it's actually a Wi-Fi coverage of the one of the campuses. So just to give you the idea of the networks. So that's what kind of networks we are having there. So on a Wi-Fi, we're having an IPv6 and IPv4, but not full IPv6, for example, because we have an Android. And if you don't know, for example, Android is not supporting the IPv6. It's supporting only prefix delegation. So the next one, we're having like 3, 4, 5G in the same time for Orange in France. Swisscom has already turned off 3G, so we're having only 4, 5, 3G. And then we're having also like teleworking, means that people by actually I think regulations can work from home sometimes, and they are also considering their network as a part of the CERN network. So we're having a Wi-Fi at home, so we're also considering them as sort of the part that we need to provide the connectivity, because what we are working for is actually a connectivity for mobile endpoints. So it's a mobile application that's installed somewhere on my phone. So that's, and on this, like, let me back to the map. So on this map, people are actually moving from side to side. They're crossing the border like 10 times a day. They are losing Wi-Fi, getting Wi-Fi. So actually they are moving. And on this move, we are having also like our observability system, and we are having the call cuts. But what usually people do when they are having the call cut on their phone, they are just calling back and just continue or switching to whatever else, like WhatsApp or. But what's the difference, for example, between us and WhatsApp? That people know where our offices are to complain. So, and some of them know where we live, actually, the engineering team. So, and also again, to give you a glimpse of details, so, but some of the call cuts that we are we're trying to find, trying to engineer, trying to solve, is actually, for this I also need to give a bit of context about how this system is organized. So, again, proxy details, it's very simple. We have a floating IP, keep alive D, nothing secret. And one of with the red line, it's showing that the main server is actually on one of location. So we have a master backup system, and this is it. So here, how it was, actually it's still now. So one of the floating IP having only one IPv4 address, and the servers by design, they're having dual stack addresses. But only v4 works. But again, internal designs, what it's showing that this floating IP, it's need to be declared somewhere, means it's internal things in a database, it need to be bound to the server, and it's having like a secondary internal DNS name, which is actually having already a dual stack addresses, so it's have v4 and v6. So I think the most attentive know what I'm going to, but to give you like an idea how it works. So again, on this map, so on the border, mobile, not mobile, so how the mobile client is working. So when are you on the call? It's getting a real IPv4 address, it's getting everything's file, call established, but during the exchange, it's also resolving back the DNS. And resolving back the DNS, it resolves back this internal address. And when the network is changing, for whatever reason, like the client is sending reinvite to reestablish the call. Just even the network change is not the reason to drop the call. It's resolving to IPv6 address. So the obvious thing is like, yeah, fix your DNS, fix your whatever, but you know, if everything would be done correctly from the first time, I don't know, maybe we won't have a job. But the thing is, like, okay, so the problem is found, okay? Actually, the solution is quite simple, so just turn on IPv6 on edge proxy, and that's fine. But what is more interesting is to test this type of scenario. So because what I'm having, it's actually not to having like Excel hell shit that Andreas shown, but I have my own like hell, but it's all automated. So how I'm testing with this tool, which actually combination of many other tools. And one of the things, actually, I don't know if you ever seen this Chroma print. It's actually a very interesting tool, which is, allows you to compare two files, compare two audio files in the sense of likeness, which is, so not even MOS, but in the sense of likeness. Like you're having your pre-recorded, for example, audio file, and you want to make sure that the signal you're receiving back is the one that you are actually expecting. With the SOCs, it's not good. You can do a sort of fingerprinting in a sense of length, in a sense of amplitude, but Chroma print is actually giving you this likeness comparison between the two audio files. And what is good, even if it will be distorted with different codecs, means the original file and the file that you are playing, it actually will give you these, it will eliminate this type of issues. So if you ever used it, I actually advise you to look on this. So what about support of IPv6 and these things? So you need a network, means to test IPv6 network, means I have it, fine. SIP supporting IPv6, no problem. VoIP patrol with recent patches. I don't know, again, if you ever seen, heard, used VoIP patrol. It's a sort of XML-driven tool for automate scenarios, different call scenarios. So, but the only thing is actually changing during the call between IPv6 and IPv4. So, and here is actually what I'm having, as already I'm using OpenSIPS, and I'm using, like, I try to fit there an RTP proxy. Like, why RTP proxy? Because RTP proxy, because of the RTP proxy IO that was, I think, presented by Max on the previous year, which you can have like on the same container within the with the OpenSIPS. So I don't need to spawn another container. I can have everything on one RTP proxy, on one container. But yeah, the thing is actually the problem that I was facing is actually support of the IPv6 in general in OpenSIPS. Because you have for support of IPv6 only one switch, like supported, not supported. And this is it. And then some magic inside happens. I was trying to force, for example, socket. It was not working. I don't know if it was gonna change in version 4. I have not tested it, but in version 3.6 it's not working. Then I had a question again about RTP proxy or RTP proxy IO, means in the same flavor. I need to work more granular with the interfaces. So I cannot blindly, for example, to run it all the 000 interfaces. I need to, for example, explicitly specify local, external, internal, because on my laptop I have a bunch of networks, different networks, and I need more granular specification of the work with the networks, and I could not find, like, nor in documentation how to make it, how to do it. So how I actually made this happen? First of all, I've added a bit of code change of OpenSIPS transformation. So now I made addition to IP resolve. I added explicit IP resolve 4 and IP resolve 6 thing. So just to mention, it's not in the mainline project, and I will come to it why it's not there and if it's ever needed actually there. And on RTP proxy, it's basically just running on the local interface of the laptop and the external IPv6 address. And on VoIP patrol, there is a magic option called reinvite, so you can specify that every 5 seconds you need to send a reinvite on the so basically that's how it is working now, more or less. So on the first invite, it's just proxying the, in blue you have signaling and red it's media. So On first invite, it's just proxying the invite over IPv4 and target as IPv4. On the second invite, it's OpenSIPS is knowing that it's the secondary invite in this call, so sort of the flip switch, and it's turning it to full IPv6, involving rtpproxy on the way. And the second and the third invite is actually just secondary invite or third invite. It's actually flipping switch. So the thing is, it's still sort of the work in progress. It's not released yet in the mainline project, and again, why I'm not convinced? Because I don't like this solution. So I would like to have it, if it's possible, some sort of different module, because the only DNS try IPv6, it's not enough for granularity of support, like for example, for external calling. With the socket, again, I think I need to talk about this on the Bogdan or everybody else on the team, because with this resolve and this magic behind the socket bonding when it's resolving the address in the moment of call, it's a lot of magic. Also, how to deal with multiple, for example, AA and AA records. Again, not clear. So I've said the new socket groups in OpenSIPS before will solve this problem. I'm not sure. Again, need to talk. And for rtpproxy, as I said, I need some help from Max here for me to help with the granularity of the interfaces. And this is basically it. So it means I was quite short, and I think we're going to have a bit more time for coffee. And yeah, all the blogs provided by the community means you. And many thanks. Let's continue.
Many thanks. Just on the granularity thing, actually we added some parameters in just released version. We're still working on OpenSIPS side. There is, I think, Razvan has pushed some of those changes
I've seen it,
recently. So maybe we'll work on it.
Yeah, I've seen these parameters, but the thing is, I need to start rtpproxy on with a higher granularity on the interfaces.
Yeah,
not
but it's
like,
already there.
It's already there.
It's already included on rtpproxy side. So you go for like 2.3, but it's already latest in when you get OpenSIPS build.
Okay.
Any other questions back here?
So maybe I'm the only one who's solving this type of problem or playing with it. But yeah, need to find the last slide. Or to put this one.
Any other questions?
I was really sure.
Okay, if we get one question, we can go have coffee now. Really? Well, I can wait. Okay, today's second coffee break is coming to us from the guys at Genesys again. Let's give them one round of applause, please. Thank you for watering us. All right, you're dismissed. Let's get back in here in about 30 minutes.
must give it a try. Receptionist.
Who's ever in the back room, still getting coffee, let's go. Thank God, Max, we couldn't start without you. We've got 3 more presentations. How's everybody doing? Everyone awake? Coffee wake you up? Our next presenter is Ron Turman from Select BV. He's going to be talking to us about SIP eSIM calls managed by the blockchain.
We're having some technical difficulties though, so one sec.
We still have battery here?
Что там?
Okay, 37.
Хватит еще на часик, да?
Sorry?
На часик хватит еще?
37.
Барабан.
Can you try to switch back to see if it still works? If it still works? The local network? No, if you go on the Wi-Fi, on the hotel Wi-Fi, just to see how bad it is. Maybe it's
SIP eSIM calls managed by the blockchain. First, let me tell you a little bit about myself. I studied AI at FU in Amsterdam. I've been working at Select for a little over a year, and I've also contributed the Auth Web3 module to the OpenSIPS project. And also, I'm very passionate about music, so if you guys had enough of the SIP talk and want to have a chat about music, just let me know.
If you get worse,
a bit about Select as
again.
well.
Okay.
It's a MVNO in Israel since 2013. We provide numbers to users using apply them to what we do in Israel. So let me just get right in and tell you about a client that came to us. A client that had eSIM numbers in a different country came to us and said that they want their users who visit to Israel, they want them to get a phone call on their eSIM number and that it would still work while they are abroad. Now we know about this scenario. You've heard about something like this before. So let's say together, what would we do? We would do some SBC routing. We would ask the end user to do call forwarding from their number that they would use in their origin country. We would ask them to forward to a new number that we provide for them when they're in Israel. And then on the server that we route the calls to, we would have in some sort of way written down to which VoIP app we need to send a notification when they're receiving a call. And this works. We know this, as I've said before. This is nothing new. But what about the app that is on the mobile device? What app is it? You have 2 options. The first one is to use an existing app. So, for example, you have Zoiper, SipHub, Linphone, Blink. These are all apps that I've used myself. They're excellent. They work amazingly. They do what they do in a very reliable way. But there is one issue that Zoiper looks like Zoiper and Linphone looks like Linphone. They don't look like what the eSIM company that came to us wants their application to look like. So what am I going to do about this? Make my own app? I could do that as well, but for that I would need to hire an iOS and an Android developer. And I don't know if you have ever tried to get an application onto the iOS store, but it's an absolute nightmare. Lega knows what I'm talking about. Afterwards, also, I need to maintain the app constantly. That's what we try to solve using Arnicon. It's a platform for client-side services. So what does that mean? That means that instead of making your own app from scratch, or instead from using an app that has specific behavior and a specific look, you choose everything that you want about the app, the way it looks, and also about its behavior, but we are the ones who maintain it. It's like a white label. It's the closest thing that you can get to your own app on the end user's device without actually the cost of maintaining it. And again, it has your choices, your style, your feel, but our maintenance. And the example that I have right there is an example from the eSIM company. So that's what their UI would look like. They decided that they want recent calls to look like this. They decided that they want to have the possibility of calling and for messaging and for voicemail that you can see on the top. They decided to also display how much percentage of the package a user has left. And why can they do this? Why can they so easily just decide everything that is displayed and what everything looks like and how everything works? We use a decentralized storage, the blockchain, in order to store data about your services and about your products. Let me just give you a few examples of what you could store on there. The OpenSIPS server IP that you want your calls to go to is one example. Specific code that should run during specific processes on the device. So for example, the first time a user has made a call in a while, you can choose specific code that would run. The cost of your services, and also your HTML. All of this you have control over by putting it on the decentralized storage. So it looks a little bit something like this. I have the example there that I showed you already, the eSIM company. Then the next one is pink and glittery because you could say that it's for the Taylor Swift PBX team to call each other internally while they're on tour. The one over there, the third one from the left, is a dial-only service. And the fourth one is also a dial-only service, but specifically for OpenSIPS. All of these are different services, but they're running on the same app. Let me go just a little bit more into detail about product installation. So how does it work then to get your product on the application? So a user would buy from your store, where they would also do the KYC. That doesn't have to be stored in the decentralized storage, of course. It's all in your hands, it's all your choices. Afterwards though, after they do the purchasing and KYC, you can still write specific data to the decentralized storage in case you want to. So again, for example, the date that the product was purchased. You could write that on there. After the purchase is completed, and we write what we want to write about the product purchase to the decentralized storage, then we can display a QR code that will load the product into the end user's mobile device. Once they reach that point, the application can fetch the product data and the data about you as a service provider from the decentralized chain and then display the application in the exact way that you want it, and to have the exact behavior that you wanted as well. Let me show you a video. If I get it with the thing that I had. Okay. Where's the box? Come on. Okay, so in this example, a user is on the website of the SecNum provider, and here, they're buying a mobile number. Again, that was their shop, that was SecNum's shop. SecNum decided to also do a Stripe implementation for payment, their decision. The user will now pay. Now that the payment was received, we can do the step of writing more information to the decentralized storage if we wanted to. And we will now display a QR code for them to scan. They do it. And now, when they're going to click Activate Number, the application will go, as I said, to the decentralized storage in order to fetch all of the information about the product and about the service provider. And the result is this. So this is the UI that they decided to show for their application. It's a simple dial pad in this case. And if they make a call now, then it would go to their server, and they can handle everything from there. So let me summarize what happened real quick. Your client, whether it is a company or a business organization, chooses their shop, chooses their KYC, their pricing, and their payment method, and this all leads to the end user having their product on our application in your client's style. Now the next question, after we have installed a product, your product, on our application is then, how do I connect my OpenSIPS server to the mobile device? Let me say a few things before I dive right into it. The application uses WebRTC. This is because we noticed that most of the calls that users make is from one client to another. So two people who have the Arnacom app. Therefore, we decided to just use peer-to-peer. In the future, we are thinking about fully supporting SIP from the application, but for now, we only have WebRTC. So you can think about the Arnacom WebRTC service as a package that also translates the WebRTC to SIP for your OpenSIPS configuration, and vice versa. But also, it handles specific Web3 authentication. Because we have a decentralized storage, which is the blockchain, we can use a Web3 authentication instead of the usual MD5 or whatever it is that you would use. And this package handles it for you. So after you install it, you can configure some things specifically for the service, for the WebRTC service side of things. Importantly, a notify port and a callback port. The notify port is the port that the client will use in order to reach the WebRTC service. The callback port is for the way back, as in from the OpenSIPS flow to the WebRTC service. You can also configure a config path and module path, which is just an extra JSON or a full-on JavaScript file with more information or more specific behavior about the service that you're running. Then a SIP JSON, which is things that you would define anyway on your OpenSIPS configuration, but it's just that I've decided to define it in a JSON so that the WebRTC service and the OpenSIPS flow will always be synchronized. Most importantly, here you define a WebSocket port, which is the port that the WebRTC service uses in order to get to your OpenSIPS flow. So again, so far the important things we did is just define 3 ports. Client to WebRTC, WebRTC to OpenSIPS, and the way back, OpenSIPS to WebRTC. Now let's talk about actually changing the OpenSIPS config file. The first thing you need to do to enable WebRTC to OpenSIPS communication is to load the WebSocket module. The WebRTC service uses the WebSocket to get into the OpenSIPS flow. For the way back, you need to make sure that whenever you have an invite that you want to forward to the WebRTC service, you just send it the information of the invite to the port that we have defined previously. Specifically, I decided to do that HTTP request from a Python script and then call Python exec from the OpenSIPS configuration. But you can do that in any way you want, and that's it, you're done. So, just to summarize, what we needed to do in order to get our OpenSIPS flow connected with the application is define a few ports, enable the WebSocket connection, and add a HTTP request from the OpenSIPS file. But what does this mean for you? What does it mean now for you and for your clients that you have managed to load a product onto our application and that your file is, that your OpenSIPS server is connected to the application as well? It means that you only needed a server and some numbers to give your client an app. Because again, you don't need to maintain it. It's a fast integration. I mean, I've managed to explain it during this presentation. It's easy maintenance since you don't need to touch the application yourself. And during this whole process, you made your own choices and you use your own knowledge. Because why are all of us here today? We are here because we know OpenSIPS. We know Asterisk also. We know WebRTC. We know all of these things. I mean, all of the presentations that we've seen today are very technical, and it's because we know what we're doing, right? So that's why I felt that it's important to stress that you can use your own knowledge. And all of these things together lead to the ability of giving new services to your clients as well. Let me explain why. If we add a new feature to the front end side, or more specifically from our side of things, as Arnacon, then you get that feature as well. I like to think about it this way. If Twilio provides API for front end, then we provide the front end and its API. Let me give you an example of the services. The SecNum application that I've talked a little bit about. It's an application that allows a user to have an extra number on their mobile device. It supports landline, mobile, call recording, and voicemail as well. Phone My Email, calls between emails basically, and also calls from emails to specific numbers. Light PBX, it's basically a very small version of a PBX meant for small players who don't want to spend a lot of money on configuring the perfect PBX for them when all they need is something very simple. It supports redirect calling, multi-ring, and IVR routing, and also the eSIM calling that I've talked about today is another service that we have managed to provide using the Arnacon app. All of these things, like the multi-ring, we support on our side of things, which means that in order to now support multi-ring as well, all you need to do is simply configure a few things. Again, the choice is still in your hands. If you want to do it in your own way, in your OpenSIPS configuration or using Asterisk, you feel free to do so, but you can also do it with us in a very easy amount of steps. I think I went a little bit fast, so are there any questions before I summarize? Yes. Of course. This one?
No, I think previous.
This one?
No. Yeah, like something like this.
Okay.
Is this configuration of your gate, is it like you send push message to your application to notify it and start on the device?
This configuration, well, okay, you kind of have.
I want to ask what prevents us, the person, to configure everything in exactly the same way and send push notification to my customer?
Well, that is kind of, I think that I didn't want to go in too deep about on service, but that is something that you can do. Because we have a decentralized notification service, then technically speaking, someone from one application could notify someone else's application, even if they have different service providers. The way that we can handle that, however, is using Web3 authentication methods. Those do go very deep, so if you want to discuss that, then we can talk afterwards. But that would be possible, to answer your question.
Do you have support for push notifications?
Yes, yes, we do. But it's done in a decentralized way, not the usual, not the usual way where you have some sort of API token in your configuration.
So you don't use Untitled push notification service and Firebase?
We do use those. Yeah. It's a little bit different, our notification sending procedures. So again, really, we can talk about it. Are there any other questions? Okay. Then I will just summarize that with fast integration, easy maintenance, and also by using your own knowledge and choices during the whole process, you can give an app to your clients and also easily provide new services. Thank you very much.
Any questions out here? Questions? Somebody? Did somebody raise their hand? Okay, let's give this gentleman one more round of applause. Thank you.
I do. You want?
Where's our next speaker? Are you waiting for the, what? Do you need the 14 minutes? Dan Bogos from CG Rates. He's going to talk to us a little bit about monitoring OpenSIPS CDRs using Prometheus and Grafana. Seems to be the trend these days, huh? I know. Everybody's supporting everybody. That's right, we have sync. Let's hope your laptop syncs.
So, hello everyone. Let's hope that everything stays in the parameters. So, thank you guys for having us here another year and for putting all the conference together. I know it's not easy given the circumstances. So, just a few words since I heard the good news that there are so many new people here. So, I'll keep the tradition and talk about a bit about the project and what's going on under the hood. So about the company, we are a company located in Germany, in Bavaria, and with back offices here in Romania as well as Albania. We got by now over 19 years of doing this thing over and over, and got quite some understanding of the seriousness of the live system outages by now, by doing both retail as well as wholesale platforms. Started before since you talked about the old OpenSIRP, so we started in that time. What is CG Rates? So CG Rates, we call it as an enterprise billing suite. It's a set of different subsystems or services, and they are designed to be pluggable easily into existing infrastructure, and also easily accommodate new components in the future. So you don't have to change your billing every time you get a new system. It's all open source. It was born in 2010, with first sources published in 2012. Our full sources are on GitHub. 100% Go language, and we have more than 450,000 lines of code written by us, plus some other libraries we use. We do have consideration for community contribution. We have currently three branches indefinitely supported. So since we have gone as a research project from beginning, we have tested the waters in different ways, and curiously all three are good. So we cannot make up our mind. However, the 1.0 is the one we will define as our way to do things in the future. It's a performance-oriented, like all the software in telecom and in real-time communication, built in an advanced caching system, which recently we converted into a real database with support for offline storage. So we became like a Redis on our own. We use exactly the same way of appending in the offline files like Redis does. At some point we were thinking to replace it because they didn't know whether they still want to have open source or not. It's just a joke, of course. So in terms of cache, we support LRU, least record used, as well as timing out the records. So we support automatic cleanup of both database as well as cache. All is asynchronous, so we use micro threads, the famous Go routines of Golang. We include an API load balancer in case of the network needs to be big and very big. And we include API servers, so everything we do is API based. In case of you willing to enhance a module which is bounded to our open source license, which is LGPL, you can do that simply by replacing completely and implementing our RPC APIs. Test-driven development from day one. We have more than 10,000 tests. I think they are way more nowadays because every developer we hire, this is how they start. So it's a very good practice for the developers, as well as very good for us in terms of coverage. We have close to 100% coverage for many packages we have. In terms of functionality, we are pretty feature rich. So the most famous functionality of ours is OCS, online charging system. We also do offline charging system, just CDRs, charging. Then we are multi-tenant, so useful for white labeling and stuff. Then we support multiple databases. We support real-time configuration reloads, rating engine with derived charging in case of you willing to, in the same time, charge supplier as well as customer as well as distributors and stuff like that. So you can do for one call in OpenSIPS 10 different calls in siege rates. Then account balance management with bundles and dynamic prepaid, which means we can also create accounts on the fly. Useful for test accounts, for example. Then session or event charging with balance reservation and refunds, again part of the OCS. Steer shaken authentication, really crazy stuff in billing because everybody does in the signaling. However, what we have done is adding steer shaking as an API, so we can authenticate the CLI on the billing side and send back the information to the switch if the switch does not support it. CDR logging with support for incoming records and rating queues. These rating queues are interesting because you don't longer need to store the CDRs in a database on siege rate side for whatever reasons. You can just maybe fire up a Docker container, rate all the calls from OpenSIPS like they would come already built on the other side. So you don't need to use siege rate storage, and you need to simply configure siege rates to disable storage and export outside towards your database. It's also useful if you have already a billing system and you want to just plug in the CDRs which are ready. Then we have a lot of number of interfaces outside for talking outside, AMQP, SQS, SQL, CSV, XML, JSON, whatever you name it. And fraud detection with automatic mitigation, this came natural because we have internally sort of own NMS, and we can monitor various things in terms of account balances, destination dialed, destination charges, total charges, and all other metrics. Then we are also, we support LCR with quality of service and bundles. So this is an advanced LCR which you can do on the billing side. Then we support call statistics with pattern monitoring. So you can tell the average call duration out of statistics and use them in your routing, for example, because LCR is not very useful if you calculate it per minute, but it could be more useful if you calculate it based on your average call duration at a certain time. So it's more accurate. Then dynamic pricing imports with templates, diameter, radius, DNS, SIP server. We even have a SIP server, but just as a redirect. So we don't support dialogues there, but just transactions. And for example, if you want to use it as a routing server via SIP, using SIP redirects. A resource allocation controller for these virtual channels in new networks. API server with many serialization support. High availability with dynamic partitioning, because at some point you cannot concurrently debit from the same account. So you will do the dynamic partitioning. Then API capturing and analysis service, sort of an encrypt, but written by us. Then clustering through various remote and replication functionalities. So since we have a database now, we can also do remote and replication. Data versioning with automatic migration, and of course we like developing new stuff. Some appliances which we have done over the years, online or offline charging, routing server. we support in terms of routing server also number portability, because this one goes again well hand in hand with routing, since prefix routing does not help nowadays so much like the same way like number portability, since a number can be totally different price if it was ported to another network. Of course, it's still in pretty small differences, because at national level we don't have so different prices. Fraud mitigation server, as I explained, statistics server. There we have predefined statistics. I'll also talk about the module itself as in my next slides. Resource utilization control, which makes some virtual resource counters. Mediation server, in case of you wanting to enhance events for billing. Then billing assurance, if you want to do parallel billing to your current billing system, and something we have recently added, IPAM, so IP address management server, sort of DHCP server. It was for us useful in IoT scenarios for mobile, where SIMs or eSIMs were coming online and they needed fixed IP addressing. Most of the providers, they only offer dynamic IP addressing for the eSIMs. As soon as you can make static IP addressing, then you can very easily make them work over their private VPNs in their network. So you can do VPNs over public network by just controlling the IP addressing. So yeah, in terms of architecture, you can see on top the agents which are talking outside of CG rates. There you can find diameter, which is popular in mobile, radius, which is mobile, as like old mobile, as well as IP networks. So IP networks, Wi-Fi and stuff. HTTP agent for REST APIs, DNS agent, enum, it's their particular implementation. There are still switches out there doing routing over NAPPR, as well as you can do enum for number portability. There are solutions requiring this, so we have support for that as well. SIP agent, as I told you, for redirects, Asterix, FreeSWITCH, Camaillo, OpenSIPS, and a separate module which we call ERS, which is Event Reader Service. All of this will convert from outside the world into internal world of CG rates, so they will send to a special subsystem named sessions, and these sessions will put the events together and make virtual sessions in CG rates. So from a channel answer, we start filing an internal session in CG rates. From channel hang up complete, or how you call it, we turn down a session in CG rates and create CDR or whatever we need to do. Then these sessions will operate over RPC or inside process with our other modules, which we call core subsystem module, but they are more or less reachable by you over APIs also, if you have to use directly APIs to them. So that would be rating, CDRs, attributes to enhance, to mediate the CDRs, chargers to do this derived charging, rating, resources for virtual resources, routes for routing, stats for statistics, thresholds. Thresholds is our internal NMS, so it monitors all sorts of metrics from inside and reacts on it by calling actions. One action can be shutting down the account if the user has top up too much, for example. So top up too much is not always a good thing. Or shut down the account if the user calls to queue up for more than 5 minutes or something like this in the last 24 hours. Then rankings, and trends. These are two new modules we have recently added, so we can see trends on the last 24 hours or last 5 minutes or whatever, and rankings to give the top suppliers, top destinations, and whatever talks you might need. IPs is the subsystem managing the IP address allocation. And then we'll have an EES, which is event exporter, and the rated events, the rated CDR, goes out from here. So we can also store it in our own store DB or send it out to wherever Amazon SQS, AMQP, even NATS we support. It's quite performant message bus, however it didn't pick up so well. In terms of session processing, we support 5 different states for a session. So one would be the session authorization. All these states, except the session update, apply to OpenSIPS. So we will get session authorization from OpenSIPS, and via this, as a reply, we can set a maximum session duration. If OpenSIPS, we say we are quite neutral. We don't impose. So we just send back the information. Is the OpenSIPS administrator who decides whether our information will be used or not. So during the communication between mod CGRates in OpenSIPS and CGRates itself, we exchange this information, returning back maximum session duration, response, resources authorization. We can also add session properties, for example, PayPal account, if one needs the PayPal account in OpenSIPS. And we also can do session routing. So from OpenSIPS, for example, dispatches module, you can use the information received from CGRates and do yourself routing with it. And the difference between the information which we send back from CGRates is that this information comes from billing, so it knows pricing. There are already super great LCR modules in OpenSIPS because it's best in routing. However, the billing information is missing there, so you cannot take decisions based on the pricing. So combining the two together, you still have the SIP pinging and everything what dispatcher can do, and you can also have the routing information based on price from CGRates. Then we get from OpenSIPS a session start. Inside we can authorize a session increment and start automatic session debits. So we do the real-time charging. In session update is not implemented with OpenSIPS because we only get start and stop. OpenSIPS does not do interim. However, session update is, for example, used in mobile world, in Diameter, where we get the heartbeat of the billing coming from the Diameter client and not from us. And session terminate, we will terminate the call and correct session counters, charging, and close the session. And we have the session CDR in the end, which is actually our product, end product, which we send upstream. This we will charge it, duplicate it, and do whatever it takes to have the things done right. Now, finally coming to my talk, how do we do the CGRates monitoring architecture? So basically, the idea is that Grafana grabs the things from Prometheus server, same like everybody, and Prometheus server grabs the things from CGRates, like all the talks up to now. I didn't hear, and this is no revolution. However, for us it's an evolution because until now we were using our own thresholds, and we decided that we can also add this to complete our solution for monitoring. And it became, in short time, pretty popular because it looks like everybody is having today Grafana Prometheus infrastructure. So this one will be just added to what you have already. So in CGRates, we wrote a Prometheus agent, which is transparently passing the queries to internal stats. So we don't do an extra layer of buffering. So we always get the stats in real time. Whenever Prometheus grabs them from CGRates, Prometheus agent will generate this HTTP pages with metrics dynamically. So whenever they are needed, the stats is queried and the answer is converted back to Prometheus metrics pages and sent back to Prometheus server. And of course, stats are gathered from all over the place in CGRates, mostly from sessions and CDRs. Then few words about our stats. Its purpose is to compute stat metrics for generic events. It's internally or remotely accessible and performance oriented, and it's using our filters as access lists. So you can define various stats, and the most important property of this is that it's all in memory. So we back them up also on disk, but we never use the information from the disk. We always have the information in memory, and this is why we can do this all this expensive otherwise to calculate ASR, ACD in memory. So you don't have to click a button and wait 5-10 minutes. You know when it happens, and you can also react to it. So you can add your own triggers in Grafana and do some things about it. Then we support multiple stat queue. You can have millions because they are very light. They are just objects in memory in the end. And you have highly configurable stats, and some of the metrics, it's the famous ASR, ACD, which are used in telecom. TCD, which is total call duration, total call cost, average call cost, post-dial delay, distinct destination count. This was popular in mobile offering. Sum, average, and distinct, also generic for events. And of course, we can also send to thresholds, as I talked about. Then this is how a stat queue profile looks like. Its configuration, so tenant and ID for each of the profiles. Filters, so here we can add any number of filters. They all have to match. So for each individual queue profile, we can say it's the customer name needs to be this, destination dial needs to be this, time needs to be this, and so on. Then weights is to prioritize when we calculate the stat profile, so we can order them and process them in order. Blocker, after hitting a specific queue profile, we can stop if blocker is true. And as you see, all these are also having their own filters. So the weight, so the priority can change based on the event. So it's totally dynamic. Then time to live, so we can keep the stats in the memory only for a specific time. Minimum items in order not to give false positive or false negatives in warnings, and to store or not this in the database, because if the statistics are, let's say, CPSs, it doesn't make sense to put it in the database, because by the time you restart, they are already obsolete. So only some stats make sense to be stored. And then the list of metrics, which can be many. These are some samples. So on the left side here, it's a sample configuration. For example, this one has a time to live. Our time to live, our times actually are in nanoseconds. So you can use them, for example, more into IoT or into virtualization if you want to calculate the CPU cycles or whatever. So it starts with nanoseconds. This one tells that the time to live for events are 5 seconds, and these are all the metrics which will be calculated. This is actually the example which you will find in the graph these are the metrics calculated for this profile. So you see average call cost is something 0.02 whatever. Average call duration is 35 seconds. These were all emulated traffic, so I hope your stats are better than this. Total call cost and total call duration. And a few words about Prometheus agent. It's a standalone component. It will bridge Prometheus queries to CGRate's internal metrics, generate dynamic pages for Prometheus, and will register handler on shared CGRate's HTTP server. So you can tell, okay, I want Prometheus to send to Prometheus agent to answer on HTTP address /metrics or /Prometheus. Then it will expose CGRates to Prometheus. It can be internal Go metrics. I'll show you in the what I mean in a graph. It can be stats metrics or it can be cache S. So also database can be exposed through this. And as configuration, you can more or less see this. This is all you have to do in CGRates to expose CGRates to Prometheus. And yeah, I hope you are able to see something. This one is the calls, total calls running through this test. So it's on 5 seconds and on 3 seconds interval. Again, it was an emulated just for this presentation. This one here is total call duration, again on 3 seconds and on 5 seconds interval. And total call cost, again on 3 seconds and 5 seconds. So you can correlate yourself by just looking at this, whether your traffic still looks okay or not. And average call duration and average call cost. So again, you can look from the commercial point of view whether you are doing an average okay. Then the last 3 graphs are taken from Go metrics from internal engine. So here will be the number of Go routines. As soon as this number just raises up and never goes down, it shows us a memory or process leak, or actually a Go routine leak. And this is always the first warning in CGRates, because we cannot really have mem leaks, because the memory management is done by Go. However, we can have mem or Go routine leaking, and this Go routine leaks will prevent this memory to be collected by garbage collector. So this one, it's a very important to at least, if it's not stable, but it should go up and down, but never only go up, because that means a deadlock or something is wrong in the software. And then you can see also memory and heap memory. You see that it's keep being collected by the garbage collector. And then you also see the process memory. This is something to do with Linux not releasing properly. It's always picking up memory, but is not releasing until you are hitting some threshold. However, this memory is kept for your process until you restart your process. So it's kept free. It's free, but it's showing as busy. This is a bit more, and why I wanted to add also the stats here. So on the left side, you can see the stat indexes here, and this is also important to be like stable and not continuously grow, because if it's keep growing, it shows us that something is not right with the queries, because we should rely on indexes. We build indexes in order to make things go fast, and if it's always increasing, it looks like the things are not going through indexes. And this one I think I don't see it, it's so small that I cannot see it. However, it's the profiles. So this one again is showing that we are hitting always the same profiles. So 3 profiles were cached and are kept there. If we configure dynamic caching, we will see that after a while they disappear from the memory. So we get transparency and feedback on what we keep in the cache. Cache is our biggest asset in terms of performance, because the difference between keeping things in the cache, so a query for the same object in the cache versus a query going to Redis, for example, which is again super fast, is milliseconds to Redis versus nanoseconds to siege rates. So you can imagine how many extra queries we are able to do just because we don't go to Redis. So that's cache, as I told you, it's super important. And with this, I made it, I hope, in time. I got it. Thank you.
Do you have any questions?
I was so clear this time, huh?
Questions? David, oh, you're getting ready. Last call. You are always so thorough. Let's give Dan another round of applause. Thank you, Dan. Man, you got to start charging for like usage on your laptop. Our last speaker, Mr. David Duffett, well known in the VoIP and RTC community. Going to talk to us about the 7 vectors of adoption.
Well, thank you. Thank you very much. And Alex, I just want you to know, there's no questions at the end of mine. I know you love walking around asking for questions, but I just don't do it. Is that okay?
I'll consider it.
Well, it's great to be here. Thank you very much for having me along. And I want to say a big thank you to Liviu, because I, in common with many other people, are having Mac problems on the projector today. So a big round of applause for Liviu. And keep it going for Liviu's laptop.
He's all right.
And we'll hope it keeps on going. So now the people that put their hands up early this morning and said it was their first OpenSIPS Summit, are you feeling the love yet? It's a loving environment, isn't it? And just to help us to get to know each other a little bit better, I don't always do this, but I thought we could do a little test. Sometimes I do a geometric test. I haven't got that for you today. I've got a much shorter and easier test, so I hope you'll play along with me. What you've got to do, and I'm going to put the microphone down for this, is you've got to clasp your hands together in front of you. Like that. Can everybody do that, please? Now, some of the most astute people in the room will immediately notice that one of your thumbs is closer to your face than the other. Are you with me so far? Okay, who are the left thumb people? Pop your hands up if you're... Have a good look round at the left thumb people. They are the sexy people in the audience. Okay, now who are the right thumb people? Keep your hands up, have a good look round, because they think they're the sexy people in the audience. Liviu, I noticed your hand went up there. Okay, great. Couple of references to earlier on. Alex was mentioning the good old days when OpenSIPS Summit was after Astracon. I remember those days well. Halcyon days, but it's great that everything's carrying on so well, isn't it? And also Flavio. Where's Flavio mentioning that people who work on SIP have bald heads? Because, yeah, so I was wondering what that says about Razvan. Is it that Razvan is the eye candy of the OpenSIPS project? It's cosmetic. Okay, well, I'm very pleased to be here, and I want to talk to you about adoption today. I run a little business called Let the Geeks Speak, and it's all about helping geeks to speak, as the name suggests. It's also about helping nerds be heard. That's the title of my little book here. Do a quick plug, Be the Nerd That's Heard. I help techies to talk, engineers to engage, and in America, I help propeller heads to propel ahead. See what I did there? With their speaking opportunities. But today, I just want to take a short time to talk to you about the art of adoption. In my presentation, the 7 vectors of adoption, because all of us in this room want to have something adopted. It might be an idea. that we want adopted. It might be an open source project that we want to be adopted into somebody's technology stack. It might even be that we want ourselves to be adopted into our next role. All of us want something to be adopted. And the art of adoption is the difference between a success, a scaling of the project, and possibly stalling the project. So it's a very important thing to talk about, the 7 vectors of adoption. And I'm sure we've all witnessed this every day in different domains, that you see a brilliant solution. And by the way, everything I say applies to all of those categories, whether it's you being adopted, your project being adopted, your idea being adopted. But for the purposes of this presentation, so I don't mention that all of the time, I'm just going to stick with technology examples. Is that okay? Good. In that case, I feel I can proceed. But we all see this, where a technologically brilliant solution doesn't get adopted for whatever reason. It happens in everyday life. Some people in this room may be old enough to remember SIP and 8323 in the early 2000s. Do you remember that? There was a lot of arguments at the time, wasn't there? I remember in Amsterdam actually running a boxing match between SIP and H323. I think the boxing gloves are probably still in the... No, okay. Yeah, it's a long time ago. But some people argued, mostly telecoms people, that 8323 was a better idea, didn't they? But the internet people run it with SIP. What about VHS and Betamax? Yeah, do you remember that? Betamax was technologically a better solution, people said, and yet it didn't win out the day for one reason or another. And so we witnessed this situation where brilliant technology doesn't get adopted, and it's a problem. We want the best solutions to be adopted. And what it means, though, and again, this is a sadness that we all live with when we look around us, that suboptimal solutions find their way in. You perhaps even work with stuff on a day-to-day basis and you think, this is not really the best way to do this, and yet somehow it found its way into our technology stack or into our workflow. And you might wonder why, why it got adopted by perhaps your predecessors or somebody else in the company. So it's a situation that we have learned to live with, but it's not ideal. Well, here's the thing. The art of adoption is not random. It's not a sort of a happenstance thing where some things get adopted and others don't, based purely on chance. There are factors that we can work on. In fact, the title of my talk said 7 vectors, didn't it? So guess what? We're going to look at these 7 vectors. There are ways to make sure that things do get adopted. The 7 vectors of adoption. Now, in my presentation skills work and my communication skills work, I have 7 power presenting protocols. And so where this comes from is a slight adaptation of those 7 power presenting protocols. Some of them have been changed, some of them have been rearranged, but here is the killer diagram. Check that out. It's not the technology itself, it's what happens around the technology that will deliver adoption or not. And you can see that adoption is squarely in the center of the picture there, with these different forces all pushing into the middle to let the idea, whatever that idea or whatever that technology might be, it allows it to get adopted. It's right in the middle. There's 7 of them, and I'm going to look at them piece by piece. When all the forces are in place, when they're all pushing at the right level, then the idea, the technology gets adopted. So as I said, whether that's something in the technology stack, whether it's you getting your next job, but the alignment of the forces is what's important there. Now, here's the difficult situation. It only takes one of them to be not quite right, and then adoption doesn't happen. So if one of those 7 is missing, if just one of them is out, we've got a stall, and it's not very handy. And I want to home in on resonance first, because that is the most difficult one to do, especially for engineering types. And most people that come along to OpenSIPS Summit are engineering type of people. They're technical type of people. They're geeks. They're nerds. They're techies. They're whoever. We like to know how stuff works and get into things, don't we? And what that means is it's not always easy for us to guess the resonance or the way we're going to resonate with other people, especially less technical people. Now, when I looked up what resonant frequency means, because I quite like radio as well, by the way, CB radios. You know what they say? There's a very thin dividing line between a hobby and a mental illness. And I've crossed that line on CB radios. I've got about 70 or 80 CB radios. There's not actually that many people on there anymore, but I just like them. I think other people in the room might have that same situation with guitars, maybe, or various other accoutrements. But I like this definition. It said the point at which a system transfers energy most efficiently. And that's what we really want to do, isn't it? If we want an idea to get adopted, whether it's getting OpenSIPS into a particular developer's technology stack, whether it's getting your code into OpenSIPS itself, whatever it is, if you want adoption, then wouldn't it be great to have the point at which energy transfers most efficiently? And I want to explain a couple of situations. Now, who in here is old enough to remember Dialogic? Anybody ever heard of it? There's a few people here. We're going down memory lane, Alex, aren't we? We're going down memory lane. Yes. Now, Dialogic, this is back in the old days. By the way, as I thought about this, loads and loads of different examples came to my mind to kind of tell you about, but this one actually jumped in first. And so back in the days of Dialogic, I worked for an English company called Acculab. And Acculab were the sort of English version of Dialogic. But, we had cards. Big old cards, full length, full height cards that went originally in ISA platforms and then later on in PCI and CPCI, the big one, and PCIe and all that sort of thing. But we did it so much better than Dialogic, because what Dialogic had is they had a card that had some ISDN connectivity on it. Wow. They also had other cards that could do very basic things with DSPs, and sometimes they strapped a little bit of ribbon wire between them on the top to make them talk to each other. By the way, we laugh about this now, but there's some of them still out there, isn't there? Still in and working and doing the job. They're still there. But in Acculab, we had a brilliant solution. Its name was Acculab Prosody. And the Prosody card not only had DSP technology that could do just about anything on it, but it also had ISDN connectivity that covered pretty much every single protocol in the world. Because, of course, you get E1s and T1s, don't we? T1s in North America, E1s in Europe. Then when you look into E1s and T1s, there's ISDN, but then there's robbed bit protocols. There were so many different, and J1s for Japan. And we covered them all. It was brilliant. And our DSPs did everything as well. They did an amazing amount. They did tone detection and tone generation. They did things like recording and playback. They even, get this, in the old days, this is on DSPs, very expensive analog devices, sharp DSPs. They did speech recognition, text-to-speech, and even speaker verification and identification. That's how cool it was back in the day. The reason I'm telling you this is when we used to run events like this for our customers, we used to spend a lot of time telling them about every single thing that this did, because it did so many things. Because the salespeople were a little bit technical, and they used to love talking about it all. And so we'd say it does facts, it does tone detection, it does error correction, it does everything. And what would generally happen at the end of it, somebody might say, that's brilliant, I'm really glad your product does all of that. I only actually want it to receive a call and then record the call. That's all I really want. So how much are you going to knock off the price for all of that functionality I don't need? Now, when you look at it, we actually explained it perfectly. We told people exactly what it did. We were trying to kind of get them interested in all that extra functionality. But at the end of the day, people only want what they want, don't they? They're not going to sort of manufacture a demand for something just to please you. And so when we worked that out, we got to a situation where we just re-engineered things very, very slightly. And what we did was, well, I just put strike through on resonance just to remind myself that it wasn't resonant. We were in there telling everybody about it, thinking we were doing a brilliant job, but it wasn't resonant because we'd not understood what people really wanted. And so what we did was we got to a situation where we subtly found out what people were really interested in. So if we've got a gathering of, 20 people, and by the way, we used to do this thing called ACE, the Acculab Communications Exchange, where we'd get people in who were potential customers, along with people who were already customers, and let them talk to each other about everything that's happened. But we'd also do presentations. And what we worked out was a way to subtly find out what was important to most people. So let's just pretend that facts was most important. Everybody really liked facts. Then what we'd do is we would deliver the presentation based on facts technology. And you could see everybody in the room thinking, flipping it, this does facts. It's amazing. And it was precisely the solution for their problem. It was resonant with what they wanted. And then we'd move on to the next one. So if we knew after facts, the next one was actually answering a call and detecting a load of tones that got played, we'd do tone detection. And so what we got to was a situation where we were delivering something resonant with the audience, and they loved it. Now, we knew that it did everything else other than that, but rather than confuse them with all sorts of technology that they didn't need to know about, we just stuck with what was important to them. By the way, did anybody start off with Asterisk here in the old days? Do you remember when you got very excited about Asterisk and told everybody everything it could do? Oh, it does all this, it does. And then you found out that the person you'd actually sold a system to didn't even want voicemail, let alone all the other stuff, the menus and the conferencing and all of that kind of stuff, and voicemail to email. You know, it's a similar sort of situation, isn't it? I mean, this replicates the world over. People don't go resonant, they go wide because they're excited about the technology. But once we'd found that formula, then not only did we sell more cards, but we sold them at better prices too. So that was the resonance factor that we discovered. So resonance isn't about explaining things better. It's not about the way you say it. What it's all about is making the message make sense for the people that you're talking to. And that sounds like a very basic thing to say, almost embarrassingly so. And yet, when we're thinking about our next encounter with people, whether it's a job interview, whether it's talking to people about buying our system, whether it's trying to get OpenSIPS community growth, whatever it is, if we're not careful, we fall into the trap of not thinking about how the people we're talking to would like to receive that information and what's most important to them. To start to do that, we have to think about the way we like to receive information and then work out from there. And I'll just give you a very quick example. One of the things that could happen is if you're an engineer and you're a typical engineer, you might learn by doing. And so you might not even have that conscious thought process about I learn by doing. You just think, oh, what I'll do is I'll put the mouse in their hands when I meet these people and I'll get them doing it themselves because that's the way they'll learn best. But it might not be. And so it's very important to have that thought process about the way you take in information and the way other people take information and, of course, what's resonant for them. And so I've got a few resonant examples here. Where do we need to be resonant? Well, here's the thing, it depends who we're talking to. The message that we give is not universal. We can't just apply it over here and then over here because they might be different people with different priorities. So what happens if it's a builder? If it's somebody that's building systems, they're going to want to know, well, how does it work? Tell me how OpenSIPS works. Tell me the fundamentals. What's the architecture? How do I install it? They want to know they want to know the technical details of the workings. But imagine if it's an operator. They're not interested in how it works at all. But they do want to know whether it's going to break. How might this thing break? And when it breaks, what do I need to do about it? What sort of reporting do I need? How am I going to get it fixed? Well, the commercial people, it's pretty straightforward, isn't it? They're wanting to know, will it sell? Can we make money on this? What are the margins? They'll have different things to consider. And then lastly, we've got the decision makers, and that could be the hiring manager, that could be the financial director, it could be the CTO. All of these people have different outlooks, and actually what they're probably more concerned about is their reputation. If I give this the green light, is it going to look good on me? And so we have to weigh these up. And so I'd invite you to do this resonance check. It doesn't have to be on these factors, but what it does have to be is an intentional step back before you have an interaction with somebody, just thinking about, well, you know, what are their priorities? And here is somewhere where Claude or ChatGPT or whichever AI you choose to use can help. So I'm going to have a meeting with this bunch of people. What's going to be resonant with them? What are their priorities going to be? Those kind of things. So, looking back at this diagram, I showed resonance as the highlighted one because that is the most important one to get right. It's the most difficult one to get right. All the other ones are important as well. And if you have any of them wandering off course, and I'll deal with resonance, then here's what's happened. We're no longer centered. If you take the resonance force away, so that's the that's the balanced one where everything's in the middle. But look what happens when we take resonance away, then it drifts. So we're no longer centered. We're no longer going to get that top adoption. But you can see there are other ones there as well. Obviously, we've got our purpose, because if the why is not clear, nothing's going to move, is it, in the first place? Then we need the attention, because if nobody sees this thing in the first place, then you're not going to get the traction. You know, if you've got an open source project that you're trying to get people involved in, then how are you going to do that? Then there's reliability. That's the big trust factor, isn't it? Massive. People are not going to work with something that they don't trust. You've got to have reliability. And you can see the other ones there as well. Continuity, a big one. What's going to happen afterwards? I was having a conversation earlier with somebody, I think it might have been Jonathan earlier, about the work you get where a company's got rid of people and nobody's left in the organisation to know how to deal with a particular situation. That's a continuity error, isn't it? People not thinking about it. All of these vectors of adoption are incredibly important. So, here's the thing. Most engineers work solely on the technology. They want the technology of the solution to work. We all do, don't we? We're fiddling about with code or vibe coding or getting something to work. We want to see it happen. And yet, very few engineer adoption. And engineering adoption is possible. Engineering resonance is possible. All of these things are possible. You just have to take the time to think about them and perhaps sometimes reverse engineer around them as well. Okay, so how can we make a difference? Well, first of all, build out clearly what you're looking for and be prepared to explain it clearly depending on the people in the room, and have that thought process about who am I talking to? Oh, I can't give this person the same message as I gave that person the other day because they've got different priorities, they've got different understandings, and they've got different things that they're dealing with. And then invite people clearly to get involved, bearing in mind that one American radio station, WIIFM. Does anybody know what that stands for?
What's in it for me?
You, sir, you just won a free book. You didn't know that there was a prize, did you?
No.
But you did, yes. What's in it for me? That's the one radio station we're all tuned into. You might be sitting here now thinking, I'm not sure this presentation is entirely for me. It's a what's in it for me thing, isn't it? But I would invite you, has anybody, by the way, seen Mars Bars ice creams? Dan's seen Mars, a few people have seen Mars Bars ice creams. Imagine when the Mars Bar man accidentally walked into an ice cream meeting, if he'd thought, oh, yeah, this doesn't really apply to me, we'd be without Mars Bars ice creams. But what he did, he had that mind-opening thought process about how can this apply to me? And now we have the brilliant Mars Bar ice cream. So always be mindful of other people's WIIFM. What's in it for me? Okay, so like so many other things in life, and we're coming in for an on. Who's our timekeeper? What time are we working on, Alex?
You got another 18 minutes.
Well, that's brilliant because I'm going to finish soon. We're going to bring it. Since you've got that extra half an hour for walking to the venue, I'm going to buy some extra time. How about that?
Okay.
Adoption is not accidental. Adoption is something that you can engineer, and so make sure you do that. It's been a pleasure talking to you about adoption, the 7 vectors of adoption. It's been a pleasure going through them little by little. But my friends, you will win business. You will get the next job you want. You will have your technology adopted if you yourself consider the 7 vectors of adoption. Thank you. But now for something completely different. It's my friend Jeff Pulver. And when he saw my LinkedIn post about the fact I was coming to see all the good people at OpenSIPS Summit, he said, can you let them know that free world dial-up is back? Anybody old enough to remember? Hey, Norm remembers it. Yeah, Dan remembers it. Or was that just a stretch, Dan?
Well, I do have a new free world dial-up number.
Brilliant.
So you'll be able to call me.
For free?
For free.
How about that?
In,
Yes.
In high quality audio.
Yes, that's the point. So Jeff Pulver, as you perhaps might know, is a godfather of the VoIP industry. Back in the 90s, he had free world dial-up based on Asterisk, connecting to Asterisk, all that sort of stuff. He's brought it back because his big thing now is VCons, and Dan and I at least know. Who else has heard of VCons in here? A few people, yeah. These are important things, and Jeff's very excited about it. And so he's relaunched free world dial-up with HD audio, because the H-er, the D of the audio, the better information can be extracted into VCons, some of the metadata and things like that, sentiment analysis, all that kind of business. So he wanted me to let you know, and so I'm doing that. But with that, Alex, I'm going to hand back to you. Thank you.
First of all, let's give this man a round of applause. Now, I know you asked me not to do the questions, but unfortunately, that's the way the cookie crumbles.
I just want to admire this young man who did do the any questions before I summarised, didn't you? Which is a beautiful thing to do. I respect that. And he still came with the questions afterwards, didn't he? It's the kind of man he is. But we can make exceptions for you, Alex.
Okay. Who are we going to make an exception of? Any questions? Stop looking at your laptops. Look up here. No questions.
How about that?
What?
Oh. I've actually got.
Did he say STD?
Because of a karaoke facility in the Laserdisc. That's what I got. He said Laserdisc or DVD. Did you have that in America?
Yeah.
Laserdiscs.
Oh yes, Laserdiscs.
Big
Yeah,
12
yeah,
inch.
yeah.
Yeah, those were the days, weren't they?
Yeah. All right, so no further questions. One more round of applause for Mr. David Duffett.
And Liviu's laptop.
Okay, so let's close up today. I have two announcements. One, 6:30, there'll be somebody from the OpenSIPS team walking everybody over to the restaurant. The location of the restaurant is on the website, so if you want to go there by yourself or with your group, you're free to do that. Dinner's at 7. And then one more reminder that we're going to be starting with, give me the name. That guy is going to be kicking us off tomorrow. He was supposed to be at the end of the day. We've moved him to the beginning of the day. We did have, unfortunately, a cancellation. But he's going to be kicking us off tomorrow, so everybody should be here bright and early.
Big up for you.
Yeah, yes, thank you. Thank you for maintaining the integrity of the schedule for tomorrow. And with that, I will open up to any questions that you might have. Nobody, right? All right. That being said, you're all released. Give yourselves a round of applause. Great first day, everybody.